Hello, good morning to all of you. A confirmation about the audio, please. If the audio is clear and available, kindly confirm. Thank you. Ziba, even in the southern hemisphere, the jet streams will move in the same west to east direction. It will move in the same west to east direction. Apply your logic about the movement of air from the hot air region to the cold air region. It will bend to the left due to the Coriolis force there. So it will be moving in the west to east direction. So the movement of jet stream is also aided by the rotation of the planet in the same direction the inertial movement is there, just like the Maran-Julian oscillation. Shalu, your question is not clear. How latent heat in tropical cyclone, as in what? Latent heat, how does it help in the case of tropical cyclone, is basically when you have the condensation process which happens, that releases significant amount of latent heat of condensation. That latent heat of condensation increases the temperature in the central portion, due to which in the central portion you do not experience any condensation immediately. And then to add on to that, when you have sinking air or subsiding air, that accumulates all the heat, and that heat is then applied to the surface of the low pressure, and that is where the temperature of the surface further increases as all that latent heat is then pushed down, and as a consequence of that, the low pressure, it further intensifies as well. So this latent heat of condensation, as long as it is continued to be released, there shall be continuation or the further intensification of the low pressure which shall happen. Balaraju, no, this Saturday we don't have a geography session. We'll have an extra session on 9th, if possible, and we'll see if we need an extra session for that. Vishwas, jet stream are present in the region of the troposphere, higher up in the troposphere, and basically at an elevation. So it varies. In certain areas, the elevation will be around uh, 16, 15 kilometers up till the level of tropopause. In certain areas, the elevation will be 6 to 8 kilometers from the surface. So it varies. Okay. So hello, good morning to all of you, and welcome to Baiju's Exam Prep. Welcome to another session of geography, where today we shall be dealing with the all important topic of Indian climate, and that is Indian monsoon, is something that we are going to cover today. Now, yesterday we had initiated the discussion with the basic atmospheric phenomena, few of the atmospheric phenomena that we experience. And in those atmospheric phenomena, we basically observed the presence of the Walker circulation, where we saw that due to the movement of the trade winds from the eastern to the western side of the Pacific, generally the trade winds move from east to west direction. So as there is the movement of the trade winds from the eastern to the western side of the Pacific, the surface water keeps on getting carried by these trade winds. And that surface water eventually ends up getting accumulated in the western portion of the Pacific Ocean. Now, there, when you have an accumulation of surface water, warm surface water, that creates or that increases the temperature in the Western Pacific, thereby creating a low pressure. Now, all the meanwhile, as the trade winds, they are basically moving the surface water in the region of the Eastern Pacific, that is near the Peruvian coastline, near the South American coastline. The subsurface water gets exposed, comes to the surface, and thereby reducing the temperature and creating a temporary high pressure. So you have a high pressure across the Eastern Pacific, a low pressure across the Western Pacific, that induces a circulation in the region from east to west Pacific, which causes rainfall in the region of Australia and drier conditions in the region of South American coastline. Now, that is what is known as Walker circulation. Walker circulation will have its arms extended even in the portion of the Indian Ocean and furthermore. Now, it is because of the circulation that it induces in the Indian Ocean, eventually, as we will see today, that how it influences the Indian monsoon as well. Now, after that, when we come to the portion of ENSO circulations, there we saw that ENSO basically indicates a movement of weather patterns between the three different conditions. One is El Nino, one is the neutral condition, another is the condition of a La Nina. Now, when we say neutral, neutral is simply the conditions which exist normally, that is the Walker circulation. La Nina is when the neutral conditions they get intensified, and there the low pressure in the western Pacific gets much stronger. The high pressure in the eastern Pacific also gets significantly stronger. And La Nina is also known as the cooling phase of Pacific, because during the condition of La Nina, almost to the central portion of the Pacific, you have colder waters or cooler waters which are present due to the factors of upwelling. Now, La Nina can cause flood-like situations in Indonesia, Philippines, Northern Australia, and so on, whereas the region of Peru will experience drought-like conditions. And then when you have El Nino is the reversal of the condition. El Nino is the reversal of the Walker circulation. Now, why does it happen? It happens when the trade winds, they end up weakening. So all the accumulated waters in the Western Pacific, they start to flow back, and they reach the regions of the Eastern Pacific or the Central Pacific, whereby they start attracting winds now. And that is where the entire Walker circulation gets reversed. That is the condition of El Nino. Now, when you have El Nino, there will be dry conditions in the region of Australia, whereas there will be heavy and significant rainfall in the Peruvian coastline and South American coastline. Then we studied a kind of a similar phenomena which also is in existence in the region of Indian Ocean. But in the region of Indian Ocean, it is by heating the solar insolation, due to which you experience different temperatures at different ends of the Indian Ocean. That is the eastern and the western end of the Indian Ocean. So that difference in temperature, it is a sea surface phenomena. So that difference in temperature of the Indian Ocean, that is what is Indian Ocean dipole, and it can induce its own local circulation, which is not as strong as the ENSO circulations, but then it can very well interfere with the phenomena of El Nino and La Nina when it comes to impact over India. IOD in itself does not impact the conditions of ENSO, but IOD can impact the role that ENSO plays on India, where we saw that in the case of Indian Ocean dipole, under normal conditions, it is the eastern portion of the Indian Ocean which will get warmer. And that is because there you have multiple different islands and water in between those islands. So as the islands get heated up and the water does not or is not able to circulate that much, the water also begins to heat up quite substantially. And as a consequence of that, the water temperature rises in the portion of the eastern Indian Ocean. Whereas when the water heats up in the eastern Indian Ocean, that attracts winds from all directions, causing upwelling in the region around Africa, causing a high pressure there. So there you have a circulation which is the neutral phase of IOD. Then in this neutral phase, if it gets intensified, that is, the low pressure across the eastern Indian Ocean gets much stronger, and high pressure across the western Indian Ocean also gets stronger. Then we have the negative phase of IOD. Neutral and negative phase of IOD are detrimental for Indian monsoon because we receive lesser amount of rainfall. Whereas when you have the reversal of condition due to heating of African mainland, you have a reversal of condition where you observe a kind of a low pressure in the Western Indian Ocean, high pressure in the Eastern Indian Ocean. That is what we refer to as a positive IOD, which is beneficial for rainfall in India. Now, in both of these, we observe that the pressure systems are fixed because the temperature conditions are fixed across both ends of the Pacific and the Indian Ocean. Now, you have in the region of equator, you have a moving pressure belt system also, a low pressure and the continuous high pressure on both ends also. So that simultaneously moves in the direction of west to east, aided by the rotation of the planet Earth. And that is what we refer to as the Madden-Julian oscillation. So that Madden-Julian oscillation basically ends up impacting the entire region around equator in every 30 to 60 days when it returns. There we also saw that if the Madden-Julian oscillation returns quite frequently, that it is able to complete its cycle, let's say within 30 days, that means it visits the region near India quite frequently during the monsoon, it can be beneficial for the Indian monsoon. However, if the Madden-Julian oscillation takes a longer period of time to complete one cycle, that means it will reach India, for example, after a long period of time. So that means it is not going to bring you frequent amount of rainfall. Then after that, we looked into the concept of jet streams, where we observed that these are very high altitude winds which are blowing in a very swift manner at very high speeds in east to west direction. And why these jet streams are in existence? Jet streams are in existence because wherever you have a difference in substantial difference in temperature of air temperature at upper altitude, that creates a relative pressure difference also, as we have indicated with the help of the image also yesterday. So that pressure difference creates a pressure gradient force, and there you have the generation of these jet streams. So these jet streams basically circulate from west to east. You have permanent jet streams as well as temporary jet streams. When we talk about the permanent jets, these permanent jets, there are two in the northern hemisphere, two in the southern hemisphere. They are the polar jet and the subtropical jet. Polar jet is formed between the ferrule and the polar cell in the upper altitude. And when we talk about the subtropical jet moves between the Hadley and the ferrule cell. So that is basically what happens in these permanent jet streams. You have temporary jet streams. One of them we'll take a look at today. That is the tropical easterly jet, for example, Somali jet. For example, when we consider the even Siberian jet, these are the temporary jets which are in existence over a small region over a small period of time. Okay, so that is basically the case of these jet streams as we have studied till now. Now, after this, we move further with the portion of the jet streams, and then we'll come to the portion of Indian monsoon. So here, when we talk about the jet streams, as you can see this particular image, this is basically the image of the subtropical jet stream. Subtropical jet, which is also known as westerly jet, because all the jets, they move from west to east. That is why it is also known as westerly jet. Now here, one thing that you have to note and significantly be careful about is, which we will use almost immediately in the next module of Indian monsoon, and listen to this very carefully. After 1 hour, when we come on this topic again, I don't want you guys to be in a position that we don't know what was there, right? So listen to this very carefully. When you observe this subtropical westerly jet, this subtropical westerly jet moves from a west to east direction. Now, this subtropical westerly jet, here you will see, gets divided into a distinct northern branch, and a distinct southern branch. Now, why does it get divided here? That is because these jets, they encounter a physical obstruction in this entire area, and that is the Himalayas. They observe a kind of a physical obstruction in the form of Himalayas. Now, your argument here can be that these jets are moving at the region of the tropopause, or at the region of 12 to 15 kilometers from the ground surface. The Himalayas are nowhere that tall. But the answer to that is that you have to understand that these Himalayan mountain ranges, they are significantly taller, average height of 6 to 7 kilometers in the region around Western Himalayas, in the region around Karakoram. So the jet streams, they move like this. So if there is any kind of obstruction, even when the jets they take a dip, then these jets they become discontinuous. They cannot move furthermore. Now here you observe that this jet stream has gotten divided into two parts, right? And this is the condition that you observe during the winter season. And how can we say that this is the condition that you observe during the winter months? Because where is this subtropical westerly jet going to be found? This is going to be found in between the Hadley and the Ferrel cell. That is around 30 degrees. But here, as you can observe, it is around 20 to 25 degrees, or 20 to 30 degrees is the entire zone. Now, as the summer season comes, what will happen? Here you can see that this jet stream has gotten divided into a northern and a southern branch. As the summer season comes, and be very careful in this, everything will shift northwards. The pressure belts, they shift northwards, isn't it? During summer, pressure belts shift north. So as the pressure belts they shift to the north, these particular jet streams, they will also be shifting to the north. So how will that shift happen? What do you think will happen in this area about the southern branch? Will it be the case that the northern branch of the jet stream is already shifting north? The southern branch will come over the Himalayas and then will further shift north? What do you think will be the situation? Here, as this portion of the jet stream it shifts northwards, northern branch will keep on getting stronger and more dominant, whereas the southern branch, its supply will get weaker and weaker, and southern branch gets thinner and thinner. And as a result of that, when the southern branch basically becomes very, very thin, eventually it will disappear. Okay, so when you have the jets moving north, so Bhavna, why will they shift north? Due to the shifting of the pressure belts. I hope we are aware that the pressure belts shift, right? So here, basically, when you have the subtropical westerly jet stream, and why the pressure belts I am saying is shifting is because the ITCZ will shift. During the northern summer, the ITCZ will lie somewhere here. So everything will shift. So if the ITCZ shifts north, the entire Hadley cell will shift, the Ferrel cell will shift, and that is why the jet stream which is present there will also be shifting to the north. So also shifts north. As a consequence of this, northern branch gets stronger and southern branch disappears. Right? Initially, the southern branch weakens and weakens till it completely vanishes or disappears. Are we comfortable with this concept? We are comfortable with this? Good. Why jet streams move parallel to pressure gradient force? That is because at a higher elevation, at a higher altitude, it is a very simple reasoning. Jet streams are examples of wind types, what we also refer to as geostrophic winds. So that is a category of winds which move parallel to the latitudes. Now here at a higher elevation, at a higher altitude where the jet streams blow, frictional force is almost going to be absent. So because the frictional force is very negligible, the speed of the jet stream will be very, very high. Now, we have seen earlier that if the speed is high, the impact of Coriolis force is also higher. So as the pressure gradient force acts, now there, due to its very high speed, the jet streams almost get impacted by the Coriolis force so significantly that they keep on blowing almost parallel to the latitude. That is why they are known as geostrophic winds. Right? Direction of jet streams is always from west to east. That is correct. Is the hitting of jet streams on Himalayas? No. Why will the jet streams hit the Himalayas? The jet streams, basically, if they could hit the Himalayas, Himalayas are a physical obstruction from where the jet streams cannot pass through, right? And then please understand that during the summer, all the pressure belts shift to the north. During the winter, all the pressure belts shift to the south due to shifting of the ITCZ. So the jet streams which are present above, let's suppose here above this is the ITCZ. If the jet stream is present here, as the ITCZ moves, the jet stream also has to move, right? But how will this jet stream move? This jet stream has got a distinct northern and a distinct southern branch. How will this move? There can be one possibility that as this jet stream is moving, both northern and southern branches are also moving. But here, in between them, you have the Himalayas. So can the jet stream simply move like this and climb over the Himalayas? Absolutely not. If that would have been the case, the jet stream would have flown over the Himalayas. So jet stream cannot simply climb over the Himalayas and cross northwards. So as the rest of the jet stream is moving north due to the shifting of the pressure belt, slowly and steadily, it is the northern branch which will get strengthened, and the supply of air to the southern branch, which moves over the central portion of India, that starts to weaken. Eventually, that southern branch will never get the supply of air. It weakens, it thins out, and then it vanishes. Okay? And during the winter season, as all the pressure belts, they will shift to the south, the jet streams will also shift to the south, but it won't be the case that it will be overriding the Himalayas and coming to the south. There, again, suddenly you will find the southern branch starts appearing, that starts getting stronger, and the northern branch starts weakening. So that shifting of the jet stream also happens, that north to south shifting of the jet stream happens due to shifting of the pressure belts. Now, when we talk about the jet streams and its impact on weather, so jet streams have a significant impact on weather. So basically, when we talk about these jet streams, they are known to be the carrier of weather systems. They carry one kind of weather system to a far away distance, and they can influence rainfall, low pressure or high pressure conditions at a far away place also, by their virtue or their property of carrying these systems or disturbances. For example, this region might have a significant amount of cloud cover or disturbance, and if there's a jet stream which comes into that area, that jet stream can carry this over distances. It can maybe form a cloud in this area, and this region will receive rainfall. Okay, so they are carrier of weather systems. But more than that, the jet streams can also influence the temperature or the climatic conditions or the weather patterns, because they don't allow the air from either sides to mix with each other, right? The jets do not allow air from both sides to mix each other. What do we mean by that? So let's suppose you have the ground surface here. Let's suppose, and here you have the jet stream. I'm talking about the cross-sectional view of this jet stream, right? So the air mass which is present on this side, the air which is present on this side, is not allowed to simply pass underneath this and the other one to pass like this. This is simply not allowed, right? And why is that the case? Because these jet streams, they are like imposition of a traffic jam. So these jet streams, they are created by the difference in temperature of the air. So there has to be this jet stream, and the air in that area is almost basically going to be static or stagnant in that region. So here, even if, let's suppose you have very hot conditions here, let's suppose you have very hot conditions. Ideally, when you have hot conditions, what do you experience? You experience basically winds to come from the nearby area and cool down the situation. But if the cool winds are situated here, right, the jet streams won't allow the cool winds to pass through, and the temperature keeps on increasing. Now, this is something which has been experienced in the region of Canada, Siberia, etc. in the past, even Europe for that matter, but Europe is slightly a complicated case. But in the region of Siberia and Canada, this has been experienced for the past couple of years or so, where they have experienced significant amount of temperature rise, what is referred to as the concept of heat dome. So there, the aspect is that the jet stream basically moves over the region of Canada and Siberia. So the jet stream, if this is the side view, this is the jet stream which is flowing. Now, during the summer months, as the heating starts to happen, as the region starts to get heated up, after the air gets heated up, the air tends to rise. Right? Whenever air gets heated up, the air tends to rise. This is your jet. So the air tends to rise, but then it meets that jet stream. And as it meets the jet stream, the air is then reflected back to the ground surface, right? So that is basically when the air is getting pushed back to the ground surface, what happens? That air will get compressed, adiabatic heating will happen. So this region gets heated up more. When this region gets heated up more, you will have more rise of air, and that will again be bounced back from this jet stream. So as a consequence of this, the temperature keeps on increasing, and no relief is provided from any nearby region because the jet streams don't allow the air to pass simply underneath them from one side to another. It is only when the jet streams they do shift during the change of seasons, that is when these areas they get some relief. This is the reason why for the past 3 to 4 years, 3 years rather, you had a continuous situation of a very high heat wave which claimed hundreds and thousands of lives of various different species in the region of Canada and in the region of Siberia, where the temperature would always tend to cross around 40-45 degrees Celsius, which is very, very high for these cold areas. And that led to significant death of the organisms. This is the concept what we refer to as a heat dome, where the jets, they like a dome, they keep on reflecting the heat back to the surface. Now, they play a crucial role in determining the weather because they usually separate colder air and warmer air. Okay, because it is due to the difference in temperature between the cold air and warm air in the upper altitude, due to which these jet streams are created, right? So if these cold air and warm air they will start intermixing, that means the jet stream will disappear. That is why that strong movement of the jet stream ensures that the air from both sides they don't end up mixing with each other, right? The difference in temperature is responsible for formation of the jets. Okay, hence the jets, due to their motion, swift motion, are able to separate the warm and cold air mass, not allowing them to mix. Okay, and think about it, why it doesn't allow the air to mix is basically, if you have, again I will bring you back to the cross sectional image. If you have the jet stream, let's suppose like this, at an elevation which varies between 6 to 12 kilometers, it varies. Here you have the jet, right? This will have associated air pattern here also. This will have an associated air pattern underneath it as well. Now think of it as a traffic jam. When you experience a traffic jam, there might be a traffic light. Let's suppose you are moving on the road. There might be a traffic light here, right? And all the vehicles are basically bumper to bumper, they are basically lined up. And you reach at this position, which might be 4 kilometers away from the traffic light. Now here you can't have the argument that, but traffic light is 4 kilometers away, at least I can move some distance. You can't, basically, because before you have so many other vehicles that have to move, right? So only when the traffic goes green, the light grows green, that is when these vehicles, they will start moving. And as these vehicles will start moving, that is when you will also end up moving. Similarly, here the air in this region does not move in this area, or this portion does not move into this region. So as a consequence of that, the air behind that also cannot move. So that is why one region continues to experience a particular kind of weather conditions. Okay. Yesterday we had taken a detailed look at the formation and the causes of jet stream. Aditya, kindly take a look into that. Okay. So now after this, we come to the portion of Indian climate and Indian monsoon, which is going to be very conceptual, which is also going to be very important for your examination. And it can be asked, it has been asked multiple times, the concepts related to it in the prelims as well as in the mains exam. So in this particular portion for the prelims, what is going to be relevant is basically factors influencing Indian monsoon, then western disturbances, rainfall distribution in India, and eventually factors influencing Indian climate. When we talk about the portion for the mains exam, so here factors influencing monsoon, again western disturbances, these are the important ones. Now we initiate the discussion first of all by understanding India's climate. Now when we talk about India's climate, it is very varied. From north to south, from east to west, you do experience different kind of climatic conditions, and that is quite unique. It is because of these different types of climatic conditions that India also witnesses varying different types of vegetation in different areas, varying different types of culture, cuisine, type of food, traditional faith, belief, our way of worship in different areas, everything keeps on varying as the climate changes from one region to another. Now, we can argue that that climatic variation in different parts of the country is, in a way, responsible for the cultural variation, the traditional variation that you observe from one region to another. And it makes India a land of diversity. Now, in this area, not many regions will you find such great amount of diversity, from the deserts to the mountains, etc. And that is why Indian climate is unique. Now, what makes Indian climate unique is the monsoon. Had the monsoon phenomena not been there, and for the monsoon phenomena to exist, the presence of Himalayas, the existence of Himalayas has got a very important role to play. That is why, had the monsoon phenomena not been in existence due to the Himalayas, influenced by the Himalayas, that thereby the northern portion of India would have been a complete desert, because the northern portion of India lies in the region of the subtropical high pressure belt. It is only during the summer, or in the later part of summer, that for those 3 months the northern part of India receives substantial amount of rainfall. Otherwise, if you consider the remaining portion of the year, you have sporadic and random distribution of rainfall, maybe once a month, maybe 2 days a month. If it rains for 3 days a month, you go hunky dory about it. You basically celebrate about it. So this monsoon phenomena is relevant for us, and in all our cultural portions, in all our literatures, we have referred to the monsoon as the harbinger of good fortune, because this is the monsoon rains based upon which the farmers would basically plant their crops, they would go for the cultivation, and that is why monsoon gods would be prayed to bring normal rainfall before the cropping season. Every part of the country that you go to, any part of the country, north, south, east, west, you'll find they have, in the local communities, they will have their own cultural tradition to worship the rain gods in order to bring them a natural rain or a normal rainfall so that the agriculture doesn't suffer. So the way of life has been shaped around this monsoon. But how did the outside world come to know about it? So, the outside world came to know about it with the help of the Arab travelers. The Arab travelers and traders, basically, they started dominating the trade routes around 10th century AD and thereafter. Now, these Arab travelers, they would basically come to the Indian coastline with, obviously at that point of time they would come with their ships. So they would come to the western Indian coastline, and they were very well aware that there is a reversal in wind direction. They were aware of the fact that the winds during the months of June, July, August, they carry you towards the Indian coastline, the western Indian coastline. And that is what would be utilized by the travelers to come to India. They were also aware that the wind pattern completely reverses during the months of November, December, January, and the wind carries you away from India. And they would use that to return from India. So they observed that there is a significant seasonal reversal of wind pattern. So that reversal of wind pattern is what was named by the Arab travelers as Mosim, meaning seasons, right? Meaning seasons. And that Mosim became monsoon eventually. Having said that, when we talk about monsoon or monsoon climate, monsoons basically represent that climatic condition where you have the seasonal reversal of winds. Of winds. Now, not many places across the world observe the sudden seasonal reversal of wind between the various different seasons. In many of the areas, you'll find that the wind direction that changes. It might happen that the wind is flowing like this, and after a few months, you find that the wind direction maybe is flowing like this. But then in India, India is one of those places, along with very few places across the world, where you have a complete reversal of wind direction. That is why India is known to be the land of the true monsoon season, because here you have a complete reversal of this wind pattern. Monsoons in India are not only about the amount of rains. Monsoons, they impact our food security. Monsoons, they impact our water security. Monsoons impact our economy. Monsoons impact our export sector, import sector, and overall the national sentiment also. History has been basically evident in that case that whenever India has suffered from a weak monsoon, the Indian economy has suffered. Why? Because the crop productivity gets hampered. Once the crop productivity gets hampered in the rural areas, people do not have that much income to spend. So the rural demand falls. People don't buy things anymore in the rural areas. So as the rural demand falls over, that is when you will have the national economy and the national production also falling, because if the rural demand is falling, you have rural India representing 65% of the Indian population. So if 65% of the Indian population is not buying anything anymore, that means what? People who are producing those things, they will halt the production. When they will halt the production, unemployment will increase. When the unemployment will increase, again more people won't have money to buy anything. So it is a kind of a vicious cycle. So that is why monsoons have got a much larger implications. Now, first of all, here we shall take a look into the factors which influence Indian climate. You have quite a significant variation in different parts of the country in terms of climatic conditions. So what are the factors which influence Indian climate? Then we'll take a look into the factors which influence the Indian monsoon, and then we will study about the mechanism of Indian monsoon before moving on into western disturbances. But rural area contributes to less than 30% of the GDP, fair enough. But even that 30%, even if let's suppose it contributes 15% to the GDP, let's assume, even if that 15% of the GDP takes a hit, doesn't the entire GDP take a hit? It always does. 2009, even though it was after the financial crisis year, 2009 was a year of El Nino, where we witnessed a substantial fall in agricultural production due to less rainfall. Indian economy started tumbling down. Indian economy, which was earlier growing around 7 to 8% after 2009, and also aided by the various different financial issues, I won't go into the economy portion, we started observing the growth rate of 4-5%. Again, in 2015-16, we again experienced deficit rainfall. That again took a toll in terms of the Indian economy, the production also. Now, let us first of all take a look into the various different factors which influence the climate of our country. One of the factor is the latitudinal extent of the country, the latitudinal position of the country. And when I say the latitudinal extent and the position, what do I mean by this? So India lies in the northern hemisphere. We are aware of that. And basically, we are also aware that Tropic of Cancer passes through the center of the country. Seema, please short up my problem because PPT and yesterday's ARM is okay. The team is looking into it, Seema. So here, when we talk about the factors influencing, so latitude, India lies in the northern hemisphere with Tropic of Cancer passing through the center of the country. It passes almost through the central portion of the country. That is the case with India. Now, what is its implications? its implications basically are that the southern part of the country, to the south of the Tropic of Cancer, those portions of the country, they experience a moderate tropical, not moderate, but tropical climate throughout the year, where the average annual temperature is perpetually above 18 degrees Celsius, right? So that means the southern part of the country experiences tropical climate with average temperature above 18 degrees Celsius. Whereas the portion to the north of Tropic of Cancer, that will experience the seasonal variations where during the summer the temperature can go as high as 47, 48 degrees Celsius, and during the winter rather you will have the temperature which can be plummeting to 2 degrees, 3 degrees, or 1 degree Celsius easily. In mountainous areas, it goes into the negative terrain very frequently and very easily. So that is what is a significant factor in terms of Indian climate. Had India, let's suppose, been at equator, then India would have experienced a different climatic condition. Let's suppose India would have been beyond Tropic of Cancer, to the north of Tropic of Cancer entirely. So in that case, no region would have experienced tropical climate. We would have experienced very colder conditions, or through and through a harsher climate. So it is because of these location that India experiences a kind of a warmer and moderate kind of a climate. Okay. So this is one of the factor. Is that understood, Reshma? Okay. How many of you have that inkling that the speed is a bit faster, or are you comfortable with the speed? Because already we are lagging behind by almost 4 modules, right? I hope with this pace, I hope that we cannot be saying that we are moving faster. If anything, we are moving very, very slow, right? But still, if you have concerns regarding that, if we are going fast, if any of the topic is not particularly well understood, given that your base is clear, see, please understand, even amongst the questions basically which come forward, many of the questions are there which immediately you are able to figure out that the base has not been revised or the base is not clear, and you are asking about a problem about maybe Walker circulation without understanding what is pressure. So in that case, there cannot be much help that I can lend. But in case your base is clear, in case you have been regular in the session, if in that case any of the doubts remain unclear, it is your right to ensure that the doubt eventually gets cleared by hook, by crook, whatever you need to do. It is your right to get the doubt cleared. So please don't basically ignore any of those areas. Whenever it comes to any portions which are doubtful, please raise a doubt, please raise a question. But other than that, I don't think that we are moving in a very fast pace. If anything, we are moving very slowly. Now, then we come to another factor which influences the Indian climate quite significantly, that is the Himalayas. Now, Himalayas have got a gigantic role to play in terms of the Indian subcontinent. Himalayas are what forms our natural borders. They are our natural northern borders. Historically, the role played by Himalayas can be summarized into many of the points. Himalayas are very, very instrumental in shaping India's geostrategic conditions, position, etc., not allowing the invaders, the Huns, and the Mongols through. So Himalayas have played their role as natural guardians of Indian border. But along with that, these Himalayas substantially and significantly influence Indian climatic condition. How? So basically, when you have moist winds coming from the region of Arabian Sea and moist winds coming from the region of Bay of Bengal. Had the Himalayas not been there, these moist winds would simply have passed over. Right? Had the Himalayas not been there, the moist winds from these areas they would have simply passed over. But because of the Himalayas, what happens? That these mountains they stop these winds and they end up causing orographic rainfall in the entirety of the region. The winds are stopped. And when the winds are stopped, they circulate and they will cause rainfall in this entirety of the area. Right. So Himalayas are in fact responsible for the greening of this northern part of the Indian subcontinent. Right. Now, over a period of time, by the way, if you even scan through the pages of history, if you go back 2,500 years ago or more, during the age of the Mahajanapadas, you'll get evidence of the fact that the northern part of the country was heavily forested. Now, it is a different matter that we have deforested that region, we have brought it under cultivation. That has virtually changed the weather pattern in that area. Deforestation leads to a change in the weather pattern. You will study that in environment and ecology also. But then, these Himalayan mighty mountains, they have been responsible for the weather phenomena that we observe. Even during the winter months, we have wind systems coming from west to east, moisture carrying wind systems. What we will study as western disturbances, they come from west to east. Had the Himalayas not been present, just like these wind systems, they cross over Iran, Pakistan, Afghanistan without causing rainfall, they would have crossed over. But because the Himalayas are present, they cause rainfall along the foothills, along the region of Punjab, Haryana, Delhi during these particular months, Uttar Pradesh, Bihar, and so on. So that is why Himalayas are significantly responsible to bring about orographic rainfall. Orographic rains, right? So orographic rains are very substantially brought by the Himalayas. Now, the other factor where the Himalayas come to play is basically during the winter months. We have seen earlier when we were looking at the pressure zones, if you try to recall, we had seen earlier that you have during the winter months the formation of a Siberian high. A high pressure zone is formed in the region of Siberia. Now that becomes a origin of the wind system. Local winds, they start moving. Right. Now, if the Himalayan protection would not have been there, the cold winds from Siberia would basically have come across the northern part of the country, and the entire northern part of the country could have experienced sub freezing temperature. So if they would have experienced sub-freezing temperature, you can forget the winter crops to be grown in that area. You can basically think about it that if, let's suppose, Uttar Pradesh, Bihar, West Bengal, Delhi, all of them would experience freezing winters with snow on the ground surface, the lifestyle would be different. The food habits in these areas would be very, very distinct, right? You would find a very distinct kind of food habit. Right now, there is a kind of a greater penchant for vegetarianism because of availability of food throughout the year. But that would have been completely changed had the Himalayan mountains not been there and freezing temperatures would have been experienced. So, in a way, by preventing these cold winds from the north to come in, Himalayas not only protect us, make this country more livable in terms of temperature conditions, but also shape up our culture, cuisine, lifestyle, tradition. Now, why continuously I keep on bringing about the aspect of culture, tradition, food, etc. It is not, because don't think about it that early morning he's talking about food. Is he hungry this early in the morning? It is not the case. Why I'm talking about this is, oftentimes you need to assimilate the various different ideas, because the questions which are asked in the mains, sometimes even in the essay paper, and even I know a couple of instances where even in the interview board, the panel has asked this question, is basically that what are the larger role, or what is the role played by Himalayas in India? Now, if you have a very abstract question like that, where it is not stressed that climatic role or climatic influence, how do you address such kind of questions? You basically then have to cater to the aspect of the Himalayas preventing the cold winds, orographic rainfall. Then, for example, Himalayas basically being the origin source of multiple different rivers, these rivers draining a large area, agriculture product, everything you have to talk about in that case. So that is why always essential, always not essential but beneficial, because majority of the candidates, they will have a unidirectional approach to the answer, where if a question has come in geography, they will only talk about geography, that terrain, climate, topography, that's it. But you are studying geography in order to understand the impact on human lives. Unless and until you bring the human factor into your answer, you won't have that edge. So that is why bring that particular aspect, how a particular influence actually impacts the life pattern, the way of living, the dressing pattern, the food habits, everything is influenced by various different geographical phenomena. That is the reason why we study geography. Otherwise, research would have been more than sufficient. Why UPSC wants you to study that is to bring that anthropogenic factor into place. Okay. Now, after this, we have another important factor, and that is the role of relief. By relief here, we basically mean the topographical variations that you have in the form of mountains, hills, plateaus, ridges, rift valleys, etc. Now, that also influences the temperature conditions, the amount of rainfall. Because when we talk about relief, we do know, as is the case with the orographic rainfall, that if you have a mountain, the winds, when they are blowing, this side is what is known as the windward side. This side is known as the leeward side. Now, across the windward side, the winds basically are pushed to rise up. The winds rise up, form clouds, bring rains, right? And on the other side, the winds are particularly warm and dry, and this is a rain shadow area. So, across the entirety of the Indian subcontinent, rainfall which is caused is heavily influenced by the varying topographical and relief features. For example, the windward side of the Western Ghats and Assam receive very high amount of rainfall. Now, in the region around, for example, in Meghalaya, you have Cherrapunji and Mawsynram, which receive the highest rainfall across the world, where on an average every year these areas receive 1143 centimeter of rain. Think about it. Cherrapunji and Mawsynram. What is the average rain in India during the entirety of year? India experiences around 120 to 130 centimeter of rainfall. Right? So think about the region of Cherrapunji and Mawsynram. Now, the second most rainiest place in the world. Where is it? It is in India itself. And where in India? Agumbe. Agumbe is situated in the western side of Western Ghats. A very beautiful place if you are ever interested in ecotourism or visiting the nature. Basically, going for a trek in the Western Ghats. Going for a trek in the Western Ghats is very different from going for a trek in Himalayas. Both have their own challenges. But nature, in its truest, wildest form, will be observed here. Here, because it is on the western side of the Western Ghats, the amount of rain is very high. And by the way, this is on a related topic. This is also a region abundantly rich in the population of king cobras. Right, this has got one of the highest density of those king cobras in the southern part of the country. You have in the nearby region, you have a cobra sanctuary which is also there. So beware about it, but nonetheless, very beautiful place to visit, especially during the rains. Now, that is where in all these particular areas you have the high amount of rainfall. And on the leeward side, so Agumbe, Chirapunji, Mosinram, these are examples of areas of very high amount of rainfall. And whereas on the leeward side, generally you will come across lesser amount of rainfall or dry conditions. So if you take a look at it, generally the conception is what? The conception is basically that as this air starts to rise up, right? As it rises up, it will cool down. It will basically, as it cools down, it basically leads to condensation to happen. It basically leads to cloud formation to happen. And after that, you have the dry air, which is devoid of all the moisture because the moisture has been brought by the rains. So that dry air starts coming down the slope. And this area doesn't receive rainfall. Okay. Now here, you have the basic pattern here. So here you will have the Himalayas. Let's draw the three parallel ranges of Himalayas. Right. Now, it is not absolutely continuous, these three parallel ranges, but that is something I leave for the portion of Indian geography where we will consider this Indian physiography. Now, if you observe this, moist winds, they come from moist winds mean many of the times I see many of you getting confused in the term moist winds. Whenever I use the term moist winds or moisture, it refers to the water vapor content. So winds coming from the water body will always be rich in water vapor. So as these winds they come over, first of all, the winds, moist winds in India, they come from during the monsoon season, they come from various different directions. Agumbe is in Karnataka, my dear friends. Agumbe is in Karnataka. So here, as these moist winds come over, they will bring heavy amount of rainfall in all this area. And listen to this very carefully, guys. This will basically aid you to or help you to understand the rainfall distribution in India also. So here on the western part of the Western Ghats, there will be an impact of rainfall due to the windward side of the mountain getting hit by these winds. Now, when these winds, few of these winds as they cross over, will they have moisture by this point of time? No. So this region of the Western Ghats, because the Western Ghats have a kind of a feature which is not like exactly like a mountain. Western Ghats have a feature somewhat like this, right? So that is why even this area tends to receive some rainfall, but not more than that. But this area is very dry. So that is why this region of India is substantially drier. In this entire region, you'll find very dry conditions to prevail. That is why the eastern part of Maharashtra, that is the Vidarbha region, the portion of Telangana, right, the portion of Karnataka, Andhra Pradesh, these are naturally very dry areas because they lie on the leeward side. Now, meanwhile, you have few exceptions. For example, when I talk about exceptions, you have the region of Nashik, Pune, Bangalore, right? Bangalore slightly to the south of it. So here in Nashik, Pune and Bangalore, despite lying on the leeward side of the mountains, they receive heavy amount of rainfall. Why does that happen? That is because of the gaps, the passage which is found to be present in the Western Ghats. You have certain gaps and passage which is found to be present in the Western Ghats, the Thal Ghat, Bor Ghat gaps, through which these moist winds are able to penetrate through. Imagine if the Western Ghats would have been continuous, even the so-called weather, or I will not give any particular name, people get easily offended. So here, those areas which are well known for the climatic conditions, that is Bangalore, Pune, Nashik, etc., where you have moderate kind of climate, cool winds blowing all year round, where they feel that because that place has got a blessing, etc. It is not the case. Had the gaps not existed in that area, these places would also have been very, very dry. Having said that, these moist winds, they move through the region of, this is what is the Arabian Sea winds. They find the Rift Valley of River Narmada. Now, Rift Valley of River Narmada is such, on both sides you have the presence of Vindhyas and Satpuras. So through those rift valleys, these moist winds, they bring through, or they come through, and they cause rainfall in the central portion around the region of Amarkanta. So that is where they observe, or you have the occurrence of rainfall, again influenced by the relief features. Meanwhile, you have these moist winds which will also try to come here. Now they face the southern portion of Aravallis in the region around Mount Abu. They will cause slight amount of rainfall. But in the remainder of their journey, you will find that the Aravallis are almost parallel to the movement of the winds. Now, if the mountain is parallel to the winds, on top of these, because they are not of great elevation, you might have some precipitation here and there. But that's it. That will be like an island of greenliness, and around it, you won't have much rainfall. This is the reason why there is nothing stopping the winds for the western portion of Rajasthan. Western portion of Rajasthan is a desert. Meanwhile, as these winds they further go north, they will hit the Himalayan ranges. As they hit the Himalayan ranges, the region of Himachal, Uttarakhand, Punjab, Haryana, Delhi, every region starts receiving rains. But observe that they will cross the Himalayas almost 3 times or more. They have to cross the Zaskar Ladakh range also to reach the region of Ladakh. Now, by the time the wind reaches the region of Ladakh, will the wind have any amount of moisture left? What do you think? Will the wind have moisture left? No. Moisture has been drained almost 3 to 4 times. This is the reason why Ladakh is a desert. It is a cold desert, though. This is the reason why Ladakh is considered to be a region of a cold desert. Now, when we talk about the moist winds coming from here, okay, here also they hit the Himalayas, causing substantial rainfall. Had the Himalayas not been present, it would have passed on straight through. But because you have Himalayas, these winds then basically get diverted. One goes here, one goes here. Now, the portion which goes here, observe, will be trapped from all different sides by the various different mountain ranges. From all different sides, there will be various mountain ranges. And that is why the northeastern part receives very heavy amount of rainfall. Every year, northeastern states receive very heavy amount of rainfall because the winds are not allowed to escape. It is like a funnel, right? So there is only one exit out of it. So here the winds, they will hit this mountain, cause rainfall here. From here, they will be deflected here. Again, they will be pushed up the mountain. They will cause rainfall. So all the winds are coming in, not having a clear exit. That is why copious amount of rainfall. It is in this region of Garo Khasi Jayantia where you have the area of Mausinram Cherrapunji receiving very heavy amount of rains. Think about it. Shillong. Shillong is only a few kilometers away from Cherrapunji and Mausinram, not more than 100 kilometers, 120 kilometers. Shillong, in an year, receives how much amount of rainfall? 140 centimeter of rainfall is received in Shillong. Because, and meanwhile, 100 kilometers away from Shillong, you have Cherrapunji and Mausinram, which receives 1143 centimeter of rains. Mausinram oftentimes 1145, 1146 also. So you have a difference of almost 1,000 centimeter of rainfall in between these areas. Why? Because Shillong is on the leeward side and Cherrapunji syndrome is on the windward side. So that is why the relief features across the country, they are very instrumental in bringing about the changed weather patterns, the distribution of rainfall, and so on. So this is one of the reasons. Then after that, you have the condition of distribution of land and water. Now, India is considered to be a peninsula. When we consider the Indian peninsula, why peninsula? Peninsula is any land which is surrounded by water from three sides. So you have the presence of water on three sides. And India is surrounded by water from three sides. Had India been landlocked, had India not had water, the conditions would have been very, very different, obviously. Now, the presence of water from three sides lends multiple different utilities. What are the importances of it? First of all, during the summer season, we do know that land and water, they get heated at different rates. We do know that land gets heated much quicker, gets heated much more intensely as compared to the nearby water bodies, due to which the land areas during the summer develop a distinct low pressure, whereas water bodies, they are comparatively cooler. As they are comparatively cooler, they will have a high pressure. Winds will always blow from a high to a low. But the winds which are moving over from the water body, they will bring moisture. They will bring rainfall also. Right? Moisture means water vapor. So winds, when they are moving over the water bodies, they will bring lot of water vapor and they will drop that as rains in that area. Okay, so this is in fact one of the earliest explanations which was provided hundreds of years ago about the Indian monsoon. And the concept was very simple in that case, that look, you have low pressure region over the surface or due to heating, and you have high pressure over the water body. So that high pressure basically provides winds, causes rainfall over India. It was only later on understood that monsoon is a much more complicated phenomena after all. It is not simply about low pressure, high pressure, but this is one of the drivers of the monsoon systems. This is one of the drivers of bringing rains. Okay. Now, other than that, you have other influences also. So, first of all, low pressure created over land areas attracts the winds from nearby water bodies. Okay, this brings rain. In India. Then, other than that, due to the presence of water body in the entire area of the peninsular part of the country, in the entire region of the peninsular part of the country, you will experience that the temperature is moderate throughout the year. Temperature in the peninsular part, especially the coastal area, coastal regions, are moderate through the year. Throughout the year. Right. Whereas when you take a look at the regions such as Delhi, when you take a look at regions such as Mathura, Agra, Chandigarh, and so on, these are the areas where the temperature goes into extremities in between the various seasons. During the summer, it will be very hot. During the winter, it will be very cold. But when we talk about the peninsular part of the country, temperature is largely consistent. It is always going to be above 18 degrees Celsius, almost on an average throughout the year. It is a different matter if the temperature drops to around 15, 14 degrees or 16 degrees Celsius. You should see the panic that strikes, that maybe we will all freeze to death suddenly, because people are generally used to a temperature above 18-20 degrees Celsius. That is why you will find very weird scenes. Even when you start moving south from Mumbai onwards, you'll find that during the month of December, January, even if the temperature is 15-16 degrees Celsius, bonfires are lit up, sweaters and woolen clothes are worn, so that the winter is so very cold. But if you go to the north and the northern part of the country, 16-18 degrees Celsius is compared to be very pleasant during these months, because the temperature plummets easily to around 2 degrees, 1 degrees as the winter progresses. So that is the climatic variation which happens from one part of the country to the other. The other aspect is the altitude, the variation in altitude. Now, different areas have a varying altitude. Now, we do know that temperature changes with the change in elevation. We do know as you move higher up, the temperature starts dropping by at a rate of around 6.5 degrees Celsius per kilometer. So that is why places even across a similar latitude, they end up experiencing very different temperature condition. Here you have the example which you find everywhere, that is the case of Agra and Darjeeling. Agra and Darjeeling, both of them are situated almost across the same latitude, almost. But they are situated at different elevations, where Darjeeling is 2 kilometers above the sea level. Now, while on an average, Agra in the month of January experiences an average temperature of 16 degrees Celsius, Darjeeling experiences 4 degrees Celsius. Right? So that is why, because of the normal lapse rate, because of the environmental lapse rate, as the temperature decreases with elevation, you will find lower temperature. Even if you consider any hill station for that matter. Let's suppose you consider Ooty and Chennai. Not much of a latitudinal difference. Right. There is some difference, but not significantly, almost negligible. If you take a look at on a world map, almost negligible difference. Chennai is oppressive during the summers, with the temperature increasing and being more than 34-35 degrees Celsius with a very high amount of humidity. Whereas at the same time, if you go to Ooty, Ooty will have a very cool climate. So there, different parts of the country, as they experience different climate or as they are present on different altitude, they will experience different climatic conditions also. So these were the factors which would influence the Indian climate. Now we come to the factors which does influence the Indian monsoon. So here we shall first be familiarizing ourselves with all these factors, and then we shall be weaving a story around them to understand the mechanism of Indian monsoon. Okay, please understand, this is I why I say this is, I have seen many of the times candidates becoming very uncomfortable that this is not the way it is given in the books. Please don't try to find this pattern in the books. Right, in the books you will find a kind of a narration of the mechanism, oftentimes confusing and not very descriptive enough. For this particular portion of Indian monsoon, I would request you, I would suggest to you, I would advise to you from all the experiences that I have, please restrict your understanding of the concept of Indian monsoon to this PPT. Once you understand the mechanism, then you are free. After that, if you have understood the mechanism, after that, go explore any research paper in this world, right? But then, if this mechanism is not understood, then virtually you will get confused every other day that, okay, why these winds are moving, why the jet stream is shifting, what is this northern, southern branch, etc. Just pay attention on this mechanism for the next few moments, and that shall be more than sufficient for your understanding of Indian monsoon. So, when we talk about the factors influencing the Indian monsoon, you have many of the factors, different factors here. So, Chennai does not experience extremities of temperature. Who told you Chennai experiences extremities of temperature? I said Chennai experiences oppressive summer conditions. During the winter, also, Chennai is hot, but it is not as hot. So I am comparing between Ooty and Chennai, which will have more warmer summer. It will always be Chennai, which will have much warmer summer, despite being on the same latitude. Chennai will have much warmer summer because it is on the sea level. Uti is at a height. Chennai experiences the winter also on an average is 20 to 22 degrees higher. So it is not as if it is in an inland area where you will have extremities of temperature. Please don't misquote or have a misconception. Now, when we talk about the factors influencing Indian monsoon, you have various different factors. We will take a look at each of these factors one by one. Heating and cooling of land and water, which happens at a different rate. That is, we do know that land areas, they get heated at a much more intense rate. They get heated much more quickly as compared to the water body. Shift in the position of the ITCZ during the months of summer, that is during the months of April, May, June, July, August, the ITCZ starts shifting northwards. Why? Because that is when the position of the sun also starts shifting northwards. During the month of June, sun is almost vertically above the region of Tropic of Cancer. 21st of June is when the sun lies vertically above the region of Tropic of Cancer. So as the movement of the sun happens northwards, the ITCZ also starts shifting northwards. Then you have the role played by the subtropical westerly jet stream. Please don't forget that subtropical westerly jet stream. I will basically remind you about that as well. This portion, this subtropical westerly jet stream that we talked about, and that it has got a northern and a southern branch, this also tends to move. So this subtropical westerly jet stream also has got an important role to play. Then heating of the Tibetan plateau and a generation of a tropical easterly jet from the region around the Tibetan highlands. We will take a look into that. This strengthens the monsoon phenomena. Mascarene high. Mascarene high is basically, you have a region in the southern Indian Ocean as Mascarene Islands, and around the region of Mascarene, it lies in the subtropics. Now, there you have a subtropical high pressure zone. We do know that you have subtropical high pressure belts, and we have also seen in terms of the earlier class where we had seen it does not exactly exist like a belt like format. It exists in the form of various different zones. So here the subtropical high pressure zone of the southern hemisphere lies in the region of Mascarene Islands. This is also what is known as Mascarene High. This is a high pressure zone around Mascarene Islands. Those of you who have heard this name for the first time in your life, kindly after the class look up into the atlas. I will show you on the map also, even though. Then you have ENSO phenomena. ENSO phenomena also influences the amount of rainfall received, and so does IOD and MJO also. Now let us one by one take a look at these various aspects. The basic of it all, the heating of the land. So during the summer months, the land will get heated much faster than the nearby water body. Water body remains cooler, land actually becomes hotter. And as the land becomes hotter, you will have the formation of low pressure. The regions or the temperatures in the region of Rajasthan, in the region of northern India. What is the temperature during the summer? For example, Haryana, Delhi, in the month of May, these regions are baking. These regions are basically experiencing temperature to the upwards of 45, 46 degrees Celsius easily. Right? So that creates a very substantial thermal low pressure. And that thermal low pressure will attract winds. Now, comparatively, water body is cooler. So this will be your high pressure. This will be your high pressure. So you will have winds, moist winds coming from here. Right. So the moist winds come there, they bring moisture, condensation happens, brings rainfall. Okay, please don't get confused that you have shown rainfall in Rajasthan. Rajasthan, as far as I was aware, was a desert, so you don't know what you are saying. So I hope you understand the larger concept here. So during the summer season, the land becomes extraordinarily hot. The nearby water bodies are cooler in comparison. As a consequence, cooler moisture-laden winds from these water bodies hit the landmass, causing rains. So this is one of the prime drivers, the prime causes of rains that India receives during the summer season. It is during this summer season that we receive that amount of rainfall, if you have observed, right? Wherever you have monsoonal climate across the globe, wherever, it is during the later part of the summer season that the monsoon rains occur. And why is that? That is because substantial amount of heating of land has happened by that point of time, creating that intense low pressure. But when we are talking about heating of land, we are talking about a thermal low pressure. Now, around the region of equator, the thermal low pressure is present where? Wherever the thermal low pressure is, it will attract winds from both the tropics, and that is the region we refer to as the ITCZ. Now, this ITCZ also shifts north and south in between the various different seasons, isn't it? So you have the ITCZ, which basically shifts, right? So during the month of July, observe where the ITCZ is. The ITCZ here moves through this region of the portion of Sahara in Africa, the portion of Arabian Peninsula, the region around Iran, Pakistan, and moves through the this particular area. That is the position of the ITCZ, right? During the month of January, this ITCZ will shift south, okay? But during the month of summer, again, this ITCZ shifts north. Now, ITCZ attracts winds from the tropics. That is why the ITCZ. By the way, why this ITCZ is shifting to the north? It is not as if as the ITCZ shifts, that is a region of low pressure. No. ITCZ represents the area of low pressure and it represents the region of thermal low pressure. ITCZ represents that area which has gotten substantially heated up and that has brought about the low pressure in that area. Okay, so that is why as the ITCZ has shifted to the north, that has basically brought about the winds. It attracts winds from the tropics. Now let us take a look at it. Sir, please discuss. What do we please discuss? Why before start of any monsoon we experience? Kindly, my dear friend, I request you guys, kindly wait for some time. We will discuss about pre-monsoon showers. Nearby, we will discuss about distribution of rainfall. Have patience. Once the session is completed and then you have an issue, ask question. Feel free to ask question, but please, as we are moving ahead with the discussion, have some amount of patience. And the worst of it all is, please don't start typing. Please tell, please answer immediately. Otherwise, the world will explode. Otherwise, the entire world cosmic things will go explosion. Please don't have that kind of an approach. Okay, let's go on ahead with the class. Nothing will happen, nothing bad will happen if your questions remain unanswered for 5 minutes. It won't be the end of the world, right? Please have patience. Now, after this, when we talk about the shifting of the ITCZ, first of all, let us draw the equator. Now, here, during the summer season, or rather, let's start with the winter season first of all. During the winter months, the ITCZ over the Indian Ocean generally is over this area. During the winter, I'm talking about. That is during the months of Jan, Feb, etc. That is where you will find the ITCZ during these months. Now, here, as the sun lies vertically above equator during the month of March, when you have the condition of equinox, that is when the sun lies vertically above the region of equator, right? Now the sun's position starts marching northwards after March, from April onwards. So during April, as the solar position comes over India, starts coming over the southern part of India, the ITCZ starts moving slightly here. Why? Because these are the regions which get heated up. These are the areas which get heated up. So there will be low pressure. Through the month of April, this will move like this. Right? Through the month of May, it will come here. Observe there's a bend in the region of the ITCZ. Why? Because the land has started getting hotter in the month of April. The land has started heating up quite substantially. So the low pressure has been developing. But there is another thing that you have to note here. This ITCZ is basically representation of a thermal low pressure. Now, during the month of April and May, observe the position of the ITCZ other than the land. It passes through the region of Arabian Sea and Bay of Bengal, isn't it? So that means ITCZ would be representing the low pressure areas in the region of Arabian Sea and Bay of Bengal during the months of April and May, isn't it? Now, an existing or a pre-existing low pressure area in these waters will lead to which atmospheric phenomena or which atmospheric disturbance will be created if you have a low pressure region, pre-existing low pressure region in these areas. Good. A tropical cyclone, right? This is the reason why India experiences tropical cyclones in the month of late April, May, and sometimes even first week of June. That is the reason, because you have a pre-existing low pressure. But after that, as the solar position further shifts to the north, there the ITCZ comes to this area, mid-June onwards. Now, or in the first week of June onwards. Now, when the ITCZ comes here, the oceans no longer have a considerable low pressure or a pre-existing low pressure. That is why June onwards, you won't experience, end June onwards, you won't experience any tropical cyclone in this area. Again, you experience cyclones when? In the month of November, December, when the ITCZ is again retreating and coming over these water bodies. That is why the cyclone season in India is April, May, rarely first week of June, but then late October, November, and December. That is when these low pressures, they basically lie over this water body. So here, basically, this ITCZ has shifted northwards. Why? Because this particular Indian subcontinent, the northern part of the Indian subcontinent, experiences very high temperature. Northern part of Indian subcontinent experiences very, very high temperature. That is why the ITCZ has shifted north, or sometimes it even comes almost to the foothills and almost to the region of the Himalayas. Now, ITCZ, basically, here, let me simplify it. When I talk about ITCZ, I am basically talking about the region where the winds from both the tropics and the trade winds, that is, trade winds from both the region, northern and the southern trade winds, both of them, they will converge at the region of ITCZ. Isn't it? Right? Now that means here also, this is the ITCZ. This will attract the trade winds. But the trade winds of the north, they will be blocked by the Himalayas. So the trade winds of the north won't be able to reach here. But what about the trade winds of the southern hemisphere, which are getting supplied from the subtropical high pressure belt of the southern hemisphere? These trade winds, there won't be much interruption. These trade winds, which are generally getting supplied from the region of the mascarene high pressure, these trade winds, they come like this. They bend to the left because of the Coriolis force. They cross the equator And after crossing the equator, the winds they take a rightward direction due to the Coriolis force. Due to the shape of the Indian coastline and the peninsula, these winds go like this. Here they will hit the Tenasserim, the Peguyoma, Arakanyoma mountain ranges, and the winds get diverted like this. Right? Now, these winds, what is their destination? These winds have not come over to India that let's chill out and let's have a good summer in India. No. These winds, their destination is only ITCZ. They only know ITCZ. Right? Again, please understand, ITCZ is what? You have multiple such low pressures. We join them together in an imaginary line. That is what we are referring to ITCZ. But virtually, ITCZ is a region of low pressure, which is attracting winds, isn't it? Now, these winds, they are coming from what direction? They are basically coming from southwest direction, right? Slowly and steadily, they will cover the entirety of India. They will advance over the entirety of the country. That is why this is also what is referred to as southwest monsoon, because the direction of the wind is southwest to northeast. That is the direction of the wind. So that is why this is known as southwest monsoon, right? Or advancing monsoon. Okay? And that is because of the shift in the ITCZ. Had the ITCZ remained near equator, this would have never happened. Okay? Now, the ITCZ is a zone indicating lowest pressure in the tropical region. It is in this zone that the winds from both the tropics will converge. It moves north and south with the apparent movement of the sun during the summer season, which is during the months of April, May, June, July, etc. The ITCZ passes through the northern part of India. This ITCZ attracts winds all the way from southern subtropical high pressure belt, which comes over India. This is the wind direction during those months. Please look at this. So here you will observe the wind in the southern hemisphere. This is the satellite image. So observe here the winds in the southern hemisphere. They will cross the equator. They will start bending to the right. They hit the Indian coastline from a southwest direction. That is why they are also known as southwest monsoon, and their destination is the low pressure centers which are present here. You have multiple of these low pressure centers, and we join a line indicating and saying that this is the ITCZ. So their destination is these low pressure cells or these low pressure centers. Is this portion understood till now? Is this portion understood? Or do we have doubts? Any doubt that we have? Ritika, if you have a doubt, now is the time to ask. Atharv, can I say that more and more intense summer in Indian subcontinent leads to? Not always. You have multiple factors, but in general, but not always. Okay, why the wind changed the path in the west side is changed or diverted? West side as in, please be more descriptive. Which portion of the world are you talking about? Rishika, there exists Himalayas. So how low pressure area in the northern India? Because the northern portion of India, that is, and when we say northern portion of India, even in the Himalayan foothills, what is the temperature in Haridwar during the summer season? If ever you have been to the region of Haridwar during summer, it is oppressive. It would virtually kill you with a heat stroke because the temperature is always perpetually above 40, 42 degrees Celsius. In the region of the northern portion of Uttar Pradesh, you have the temperature easily in the range of 40 degree plus, right? So the temperature is always very high in that area during the summer. That is why, because that is a dry region. Dry region means not much amount of rainfall. So if not much amount of rainfall, heating is quite significant. Haryana, northern Rajasthan, Punjab during summer in itself is almost intolerable, right? So that is why you have significant low pressure. Yes, Musharraf, it does. And then Aditya, in this part, in this map, explain western side monsoon. What is western side monsoon, Aditya? And before the start of monsoon, we'll talk about the pre-monsoon shower later on with it. Sandeep, why there is no rain in the high pressure wind colliding Indian west side? I will come to the portion of how rainfall happens, why the onset of monsoon happens, when it happens. I will come to all of that. As of now, are we comfortable with that? Why that reversal of wind happens, when that happens, retreat of monsoon, withdrawal of monsoon, everything I'll deal with it. Don't worry. Till now, is there any issue? Yes, Sulakshana, that is correct. Shyam, why in August, and we'll come to the August and September later on. And what is that circular motion in the south? Hmm. That is a question that I was about to ask, but you stumped me into this. Rajan, when the ITCZ is on north of India, then why the wind got diverted when it returned from Africa to the west side of India? It turned into south and then go into the east side of India. This is basically because of the shape of the Indian peninsula. This diversion that you see is because of the shape of the Indian peninsula landmass. And then this movement to the right that you see is because of the ITCZ. Okay. Now, here, no, Garu Khasi Jaintia are not part of the Shivaliks. If at any region low pressure is created, then it means that ITCZ automatically reaches. What is ITCZ? What do you understand by ITCZ? Is ITCZ a person? Is ITCZ an individual, head of state? Is ITCZ a phenomena? No. ITCZ is a continuity of the, or what an imaginary line that you draw in the region of the thermal low pressure around equator. That is your ITCZ. Why it is referred to as ITCZ is because in these low pressure centers, winds are attracted from both the tropics. That is why we refer to it as ITCZ. I will tell you about all the rainfall distribution, etc. Don't worry about it. I'll tell you the mechanism of Indian monsoon also. This is just about the shifting of ITCZ, as I was telling you. When I say shifting of ITCZ, what I basically mean by that is that in the month of, let's suppose, January, you had low pressure centers here. In the month of May, you might have low pressure centers here. In the month of June, the low pressure centers get created here. And that is where the winds start getting attracted to. Okay. So that is where the winds basically move into that region. And right. So that is basically the aspect of the shift of ITCZ. We'll come to the other reason. But before that, do you need a break now or can we continue up till 8? In Arabian Sea, um, where the trade winds which follow east to west, I understand that wind diverted from Africa, but the direction changed. The direction here changed because in the northern hemisphere, the Coriolis force bends to the right, bends the winds to the right. In the southern hemisphere, the Coriolis force bends the winds to the left. That is why the wind is to the leftward direction in the southern hemisphere. It bends to the right in the northern hemisphere. Okay. Okay, fair enough. I'll give a break. But I'll give a 10 minutes break. I won't give more than that. So take a break for 10 minutes and let's be back. ITCZ is also present over Africa. Yes, the ITCZ is also present here. ITCZ is also present in this region. But the problem is that the winds, these winds won't be able to reach here. This will attract winds from this region, right? This region. That is what the African ITCZ will attract. And as these winds cross over the entirety of the continent, they will be very, very dry by that point of time. That is why they don't receive rains. So because the winds will get deviated due to Coriolis force, that is why they will bend to the right. Okay, so that is basically the portion of ITCZ. Anyways, let's take a break and be back in 10 minutes, and we'll continue with the other important factors such as the westerly jet stream, the subtropical jet stream, it's shifting north and south of that jet stream, and so on. Okay, let's take a break. A confirmation about the audio, please, guys. If the audio is clear and available, thank you. So that is the movement of the ITCZ that we looked into. There are other factors also involved. One of the important factor which plays an instrumental role in terms of the onset of Indian monsoon is a subtropical westerly jet stream. Now, before I go into the details of how subtropical westerly jet stream actually influences the onset, think about a logic. Apply your common sense here. Every year, the position of the sun is above the Tropic of Cancer around 21st of June. Every year. It is not the case that this year it is a good year. This year it is an election year. So this year you will have the sun over India in the month of March only. It is not the case. So the movement of the sun is almost the apparent movement of the sun is consistent with date. That means the shifting of low pressure should also be more or less similar. But why is it the case that you will find that till the last stage, that is, till the month of May, the scientists, the climatologists, they are clueless about when the monsoon is going to arrive? Look at the various different press releases that they come out with. You will find that all of them, all the various different climatologists, the Indian Meteorological Department, what is the forecast that they give you? Monsoon might arrive early this year. Monsoon might arrive late this year. Monsoon might come in the first month of May. Monsoon might come in the in the last week of May or in the first week of June. Why that uncertainty? We have seen that the shifting of the ITCZ has brought the moist winds almost till the Indian coastline. Yeah, but the rains don't happen. The onset of monsoon doesn't happen. Why? Because there is another beast like climatic phenomena, if you think about it, moving over the Indian subcontinent during these times. And that is the prevalence of subtropical westerly jet stream. Now, this subtropical westerly jet stream, again, I will have to take you back. When we talk about this subtropical westerly jet stream, this is the jet stream that I am talking about, right? Now, during the winter and the summer months, this jet stream moves. Because of the movement of the pressure belts, this jet stream will also be in motion. We do know that during the summer, the pressure belts, they will shift north. As you can see, due to the presence of the Himalayas, the jet stream has got two branches. It gets divided into two branches. You have a distinct northern branch and a southern branch, which moves over the central and the southern portion of India from the region around Hyderabad. Right. This jet stream can be observed around the region of central Maharashtra and also over the region of Hyderabad is where this said southern branch of jet stream will be detected. Now, this subtropical jet stream also during the summer, as the ITCZ shifts north, this entire setup also tries to shift north. But we are not talking about a small column of air which is shifting north or south. We are talking about a large band of wind pattern which is in motion for thousands of kilometers altogether. So if let's suppose this particular portion shifts, the other portion will follow. Right? So that is how it happens. If this portion I shift it like this, the other portion has to follow, but there will be a delay. So as this particular area of the jet stream, the western end of it, that shifts northward with the shifting of the ITCZ, slowly and steadily the northern branch keeps on getting stronger and stronger. And the wind supply to the southern branch keeps on getting weaker and weaker. But as long as there is a southern branch which is in existence over the Indian subcontinent, it won't allow the winds to come through. It won't allow the winds to move. Why? Remember the traffic jam example that I gave you. That it might happen that a traffic jam is 5 kilometers ahead of you, but there are cars lined up. So even if you are 5 kilometers away from the traffic signal, you won't be able to move unless and until the signal goes green and all the cars move. So this is how it will influence. Now let us take a look, a detailed look. So first of all, let's draw the equator for references. Now, when we talk about the winter season, the ITCZ is also south, right? So the jet stream is going to be present somewhere in this area. You will have a distinct northern branch and you will have a southern branch also. Now, the summer months, they start to come in. The pressure belts, they start shifting north. With the northward shift of the pressure belt, this will also start shifting northwards. So as this will start shifting northwards, observe that the northern branch keeps on getting stronger and the supply of air to the southern branch, that starts to weaken. The supply of air to the southern branch starts to weaken. So the southern branch of this jet stream starts to weaken and thin out, right? It becomes thinner and thinner, but still it is present. Now, furthermore, this jet stream will shift further north. As the peak summer comes in, this jet stream will shift further north, further strengthening the wind supply to the northern branch. Right? Meanwhile, the southern branch continues to go weaker and weaker till one day will come when the southern branch disappears. As soon as the southern branch disappears, immediately all the moist winds which had come up till this position but were not moving forward, all these moist winds immediately, first of all, will hit the Kerala coastline. And now the winds will start moving with all the pent up energy. Kerala coastline will receive 5 to 6 days of continuous rainfall almost. And that is when we say it is known as the onset of monsoon. But here you might have a question that the jet stream was present over central India. The winds had already come to Kerala. Couldn't the winds have caused rainfall in Kerala? At least Kerala would have got some relief. And then we would have taken the care of the rest of the country later on. So remember always, when you have the jet stream in question, let's suppose this is your jet stream. So, as I told you in the first part of the session here today, that the air underneath is not allowed to mix. So, the air in this region, even if it wants to rise up, even if it wants to come here, it won't come. That means the air in this area won't be able to move. If this is the Kerala coastline, so you will have the air which is trying to move but is not able to move. So, even if the moist winds have reached till this position, they won't be able to move forward unless and until the jet stream moves. The moment this jet stream disappears, the moment the southern branch disappears, immediately you will observe all these winds to move. They will reach the region of low pressure. Immediately they will start rising up. There will be a swift movement. This moist wind, which had reached the Kerala coastline, will hit the Western Ghats. The entire landmass has been so heated up. There will be convection at multiple levels. I won't go into the details of the different types of convection, but in case, I don't know if you are aware or not, you have convection happening at multiple levels. You would have seen clouds at multiple levels. If ever you have got an opportunity to fly from one region to another, you would notice that there are clouds near the ground surface, then there is an empty space, and there is again another layer of cirrus clouds and the high altitude clouds. So when you have that sudden onrush of winds, so you will have convection happening both near the ground surface as well as in the mid mid altitude, and that creates superb amount of convective current which is unforeseen, and you have very dense and thick clouds which are created, which have a thickness of 10 kilometers and more. That brings thunderous, heavy, continuous, violent rainfall. And that is when we say that the onset of monsoons have happened. Now, the scientists or the climatologists, the reason why they are unable to predict when is it that the onset will happen, they don't have the prediction. Even now, you will find, and I understand that this year you might not be very well aware, but next year you know this. So, next year in the month of March, pay attention. You'll find that till the last moment, the meteorologists they will have the prediction that the monsoon might arrive next week. The monsoon might arrive on 1st of June. The monsoon might arrive on 2nd of June. Why is that? Why is that unpredictability there? Because jet stream is still a very much an unknown phenomena. And the meteorologists, the climatologists, they are not fully aware. Basically, you cannot calculate when that southern branch will disappear. It might vanish 27th of May, onset can happen 28th of May. The southern branch of jet stream might stay till 2nd of June, onset will happen after 2nd of June. The moment southern branch of the jet stream will vanish, onset of monsoons will happen. Sometimes it also happens that you have the reappearance of this southern branch of jet stream due to the shifting of the jet streams. Sometimes there is a reappearance of the southern branch during the month of August. You'll find that suddenly in the month of late August and September, as all the pressure belts and the jet streams again start shifting to the south, suddenly it will reappear. Immediately, as the southern branch reappears, there is cessation of rainfall. The amount of rainfall then reduces drastically, and India receives dry August and dry September. So that is how instrumental this subtropical westerly jet stream, and more particularly the southern branch of subtropical westerly jet stream, that is how important it is for Indian monsoon, particularly the onset of monsoon. So here, these are the jet streams which tend to develop over the region of subtropical high pressure belt. During the winter months, these jets lie over the northern part of the Indian subcontinent, having a distinct northern and a southern branch. With the onset of summer season, as the ITCZ shifts north, the southern branch of the jet stream starts weakening. The moment this jet stream disappears, I will write it down as well. The moment the jet stream disappears, and not the entire jet stream, southern branch, or simply vanishes, it triggers massive movement of air, moist winds, which have waited at western coast, hit Kerala and cause substantial rain. This is what is known as onset of monsoon. Okay, this is what is known as the onset of monsoon. And I don't want to go into substantial uh, technical details of it, but I think you should have an idea here. When you have very intense low pressure, the air is very heated up. Remember the summer season. It is very heated up, ground surface, air above. So you have so much of low pressure During the time when the jet stream suddenly disappears, as the moist winds come, they come at various elevations. As they come at various elevations, here also they will rise up, here also they will rise up. Now, these are moist winds, very heavy in moisture. So condensation will happen very easily. So they will lead to significant amount of condensation here also, here also. Multi-layered clouds are easily formed. And this continuous process leads to a continued rainfall in many of the areas in the initial part of the monsoon, if you recall. You have continued rainfall in many of the areas for 4 to 5 days continuously, or 5 to 6 days continuously. That is what is also known as the burst of monsoon, where due to the disappearance, remember this and listen to this carefully, due to the disappearance of the southern branch of the jet stream, you have significant and tremendous amount of convection happening both at the surface and at mid altitude. This leads to formation of copious amount of cloud, large and thick multi-layered cloud formation, which brings continuous rain for 3 to 4 days as this process of convection is continued. This continuous rainfall after the onset of monsoon is what is also regarded as the burst of monsoon. Burst means sudden occurrence. So, burst of monsoon, continuous rainfall for 3 to 4 days after the onset has happened. And when do we declare that the onset has happened? When you have a parameter or the expected amount of rainfall received in Kerala, that is when we say so. Now, there is another factor, that is the heating of Tibetan highlands. Now, this is a factor which is going to strengthen the monsoon, right? It is not the driver of the monsoon winds, no. It simply ends up strengthening the monsoon. It makes the winds stronger. It makes the monsoon winds much more stronger. So I will write it here itself. The role played is role it generates upper air movement of wind it strengthens the monsoon. It is not the main driver of the monsoon phenomena. Not the main driver of monsoon phenomena. Okay. Now, when we talk about Tibetan highlands, these Tibetan highlands, which have been created due to the folding and the reverse faulting, which has simply pushed up the landmass, they represent the highest plateau across the world in terms of the average height. On an average, the height of the Tibetan highlands is around 5 kilometers above the sea level. And much of these Tibetan highlands have the presence of basaltic rocks, the dark colored rocks. Now, what that means is that during the summer season, sometimes, not always, sometimes, in certain years, they get extraordinarily heated up. When they will get heated up, that is when they create a very intense low pressure over the region of Tibetan highlands. Very intense low pressure. Due to this intense low pressure, in fact, due to this intense low pressure, air starts rising up in this area vertically. You have such an intense low pressure, air starts rising up. As the air starts to rise up, it will move out. It moves out in all different directions. Right? And that is when a circulation is actually induced. That is when the circulation is induced. And this circulation, eventually, we will see, influences the Indian monsoon. But before that, if you recall, I had told you that not every year this happens. Why? That is because there's a variation. Sometimes during the winter, the region of Tibet receives very heavy amount of snowfall, and that snow gets hardened into ice. So the snow will start melting. Sometimes the melt continues even up till June and July. So in that case, there won't be much time for the Tibetan highland to get heated up. But sometimes, let's suppose the amount of snowfall has been moderate to less. The snow would have melted by the early week of May. Then by the month of June, you will have a substantial low pressure created, and that can influence the monsoon. So not every year you have the same phenomena, right? By the way, when I say upper air movement, I hope I'm clear about it, that I'm talking about the upper troposphere, in the region of troposphere. Do you need? I think that is more than understood. Now, why is it that these Tibetan highlands, they generate that much amount of low pressure? Is because of the heating. But how is it that it influences the Indian monsoon? So let us understand that. So here, let us have a brief schematic image. Suppose these are the Himalayas. Just a kind of a reference for you guys. This is not an accurate image for that matter. Obviously, will never be accurate for that matter. If let's suppose this is your equator, let's suppose this is the region of subtropical high pressure. High pressure of the southern hemisphere, right? In the southern hemisphere. Now, as I have already told you, the subtropical high pressure for the southern hemisphere lies where? In which portion does the subtropical high pressure lie? Are we aware of that? In which region? Very good. Good. Rohit, Akhilesh, good. Kartika, Animesh. It is around the Mascarene Islands. That is where you have the Mascarene High. Now, this gets tremendously heated. See, understand, when I say tremendously heated, it might have a temperature of 15 degrees Celsius. But at that particular height, it is more than sufficient. It is very, very low. A 15 degrees Celsius at this height can create a very intense low pressure. Why? Because a simple comparison I will give you, I will rub this later on, don't worry. So here, let's suppose you consider the region of any area of Uttar Pradesh having a temperature of around 40 degrees Celsius, right? This is at an elevation of 5 kilometers. At a height of 5 kilometers, here if you have a temperature of 15 degrees Celsius, here at a height of 5 kilometers, if you consider the air to be dry, because we are talking about the summer season, let's consider the lapse rate to be 10 degrees Celsius per kilometer in the case of dry lapse rate. So what will be the temperature at an elevation of 5 kilometers here? What do you think will be the temperature here? Very good. It will be minus 10 degrees Celsius, isn't it? The temperature will be minus 10 degrees Celsius here. But in the same altitude, Tibet is experiencing 15 degrees Celsius. Much variation, significantly high variation. So here automatically, because you have a substantially hot land surface, that means you will have a kind of a, okay, I will let it remain here so that you have a point of reference. Lapse rate, dry lapse rate of 10 degrees Celsius per kilometer. Now, this is where the air will start rising up due to excessive heating. The basaltic rocks, they will get absorb more heat. The air will start to rise up. Now, the air will very quickly reach the level of tropopause. because generally in the atmosphere, we have seen that the circulation is restricted up till tropopause. Air very quickly reaches tropopause and then it diverges in various different directions. As I indicated here, it will diverge in various different directions, right? Other directions are not important for us. We have one of this wind which actually moves like this, bends to the right due to the Coriolis force, then starts moving. If I have to indicate the upper air movement I am indicating. Okay, please don't get confused, guys. I am indicating the upper air movement. Here the wind is rising up. It diverges in all different directions. One of them moves like this, then basically deviates to the right due to the Coriolis force. It then follows the Kolkata-Hyderabad axis. It is the upper air circulation I'm talking about. Kolkata-Hyderabad axis here. Crosses the equator, then starts bending to the left, eventually falls in the region of the subtropical high pressure. High pressure. Right? This yellow color represents upper air wind movement. Okay? So you have that rising air which starts rising up. Okay, but won't the Western Ghats form a barrier? That is why I was writing it here. Okay. Now, observe this image. It rises up, it moves here, crosses the region of the Himalayas here, moves over here. It is still in the upper portion of the ITCZ. It comes here, crosses the equator, bends to the left, comes to the region of subtropical high pressure belt, and then it starts to sink around the region of the subtropical high pressure belt. Now, we already have from the region of subtropical high pressure belt, we already have the movement of the winds on the surface, which is coming towards India. Right? We already have the movement of the winds coming over to India, and these winds basically are already causing more than enough rainfall in different parts of the country. They are causing rains in different parts of the country due to convection, heating, etc. Right? Now, when you have more of this wind coming from the region of Tibet, more of the wind coming from the region of Tibet means what? There will be more air which will sink in the region of the subtropical high pressure here. And when you have more air which will sink here, will mean what? More air from there will be supplied over to India. More air will cross over to the Indian subcontinent. It means more moisture is brought over to the Indian subcontinent. That means the monsoon gets stronger. So this upper air movement that you see, here the wind is moving over a short distance and it exists only for a short duration of time. The wind speed in this region is around 80 to 100 kilometer per hour, sometimes slightly even more, depending upon the seasonal variation. So this upper air movement is what is also referred to as tropical easterly jet. This is what we know as a tropical easterly jet. Why? Because of the direction that it takes from an east to west direction. What about the subtropical high pressure belt in northern hemisphere? It will be further northwards. Subtropical high pressure belt during this time of the year is significantly northwards above the around the region of China. It is not present over India during the season. During the summer season, as the ITCZ shifts north, the entire movement of the pressure belts will happen. So this is your temporary jet stream. So this jet stream strengthens the Indian monsoon. So this is your upper air circulation. This is your tropical easterly jet. Now, what this does is basically it fuels the wind movement on the surface. These are your surface winds. So please don't think about that. Won't these collide with each other? We are talking about a difference in the altitude where the winds are moving. These surface winds, more winds will be driven towards the Indian coastline and more rains will be received. This is your surface winds. They are known as temporary jets because these are the upper altitude, high velocity movement of winds which are observed, and hence they are known as jet streams. Okay, now during the summer months, these rocks in the Tibetan highlands they become very hot. They form an intense low pressure region over Tibet. Resultantly, the air rises up and diverges from a height. The divergent air goes all the way to the southern hemisphere and sinks over the region of the mascarene high pressure, which is a subtropical high pressure in the southern hemisphere. This upper air movement is sometimes referred to as tropical easterly jet. This forms an important cycle to strengthen the monsoon. It makes the monsoon stronger. Does not mean that in some year, if the tropical easterly jet is not there, monsoon will not happen. No, it simply makes the monsoon stronger, right? So that is the role that it plays. And it depends, depending upon the fact that, for example, this year, let's suppose, right now, when we come to the month of uh, November and September, November and December, the temperature is already below freezing point in the region of Tibet. Let's suppose that region gets so significant amount of snowfall and ice formation that ice will melt by the month of June, July. Then this tropical easterly jet won't be created. You won't have that much convection and the divergence of wind in the upper atmosphere. But when you have the condition where, let's suppose this year the snow has fallen, but it will start melting by March, April, and May, then by the month of June end, there will be that generation of the tropical easterly jet, which will strengthen the Indian monsoon. Okay. So that is the aspect of the strengthening part of the monsoon. Now, here, when we talk about the driver of these monsoon winds, so the monsoon winds are generated from the subtropical high pressure belt in the southern hemisphere, that is the Mascarene High. This is a region of high pressure around the Mascarene Islands. Now, it is from this high pressure that the winds are driven and they cross the equator and they reach here. So that means stronger the mascarene high pressure, any factor, any climatic influence, any climatic circulation, any atmospheric circulation, stronger the high pressure, more will be the winds driven towards the Indian coastline. Weaker the high pressure, less will be the winds driven towards India. So stronger high pressure, more winds. Stronger is the monsoon. weaker that high pressure, or any influence which weakens the high pressure, that weakens the monsoon phenomena also. So here, if you take a look at it, this is a zone of high pressure which exists around Mascarene Islands in the southern hemisphere, and hence the region is known as Mascarene High. During the monsoon months, when it is winter in the southern hemisphere, this region of high pressure is the source of, please understand, when we have the monsoon season, it is the summer season in northern hemisphere, it is winter in the southern hemisphere. The source of these winds, the high pressure is the source of these winds, which travel across the Indian Ocean to reach the ITCZ, which lies over India. Stronger the high pressure, more is the rainfall received during the monsoon season. Now, then we come to the influence of El Nino and La Nina. How do they end up influencing Indian monsoon? Now, El Nino and La Nina, again, if we talk about the basic of it, El Nino and La Nina, they end up influencing the Mascarene High. So, these events, they influence the pressure, the strength of the pressure on Mascarene High, influence the strength of high pressure at Mascarene Islands. Okay. So basically, when we talk about the La Nina conditions, La Nina conditions, if you observe, the western part of the Pacific Ocean will have the low pressure. So the winds will come here, they will rise up. The winds will get diverged here. The winds will get diverged. That basically the wind here, observe, it sinks. So in this region, you have the strengthening of the high pressure. Sinking air strengthens the high pressure. Right? So if the high pressure is strengthened in that case, what does that mean? Means more winds will blow towards India. Means more winds blow towards India. Right? Means more rainfall, because all these winds are coming over to India after covering hundreds of kilometers, thousands of kilometers over water bodies, so they are heavily moisture laden. So due to heating of the western Pacific in the condition of La Nina, there is a creation of a low pressure over the region. The air rises up, forms clouds, and after that diverges from the region of tropopause in the eastern and the western directions. The part which moves to the west, eventually, part which moves to the west, this portion, eventually subsides in the region of a Mascarene High, thereby strengthening or making the high pressure, Mascarene high pressure, stronger. That strengthens the intensity of monsoon winds, causing more rainfall. What about El Nino? If you observe the El Nino circulation, you have sinking air column here in the region of the high pressure in the western Pacific, right? It is the eastern and the central Pacific where you have the condition of low pressure. But observe this circulation. Here, you will have wind which moves in both direction, right? And here, you have a kind of a rising air in this vicinity. What does that mean? That this strength of the high pressure is weakened. So that means lesser winds coming over to India. So due to the heating of the eastern Pacific, there's a creation of low pressure over the region, and the air rises up, forms clouds, and after that diverges from the region of tropopause in the eastern and the western directions. Now, the part which moves to the west induces a circulation which eventually weakens the high pressure system over the region of the Mascarene High. That means lesser winds are pushed towards India. That means you have lesser amount of rainfall experienced in India during El Nino. Even if you don't know the reason why that happens, even if you are just aware of the fact that El Nino means less rainfall, La Nina means more rainfall in India, more than sufficient. Okay, even this much basic information, that El Nino means less rainfall in India, La Nina means more rainfall in India, that is more than sufficient to deal with any of the GS questions, right? If you want to go into detail, there are many more details that basically it is kind of an endless detail, where you also talk about the ocean movement, the oceanic water movement, etc. But let's not go there. So this is basically the impact of El Nino and La Nina. Then the Indian Ocean Dipole. Now, Indian Ocean Dipole has got various different phases associated. Right. First of all, let us draw the equator here. So it has got various different phases. What is it that we know about the condition of IOD? We do know that whenever the Indian Ocean Dipole, that is neutral or negative, means less than normal rains in India. Even this much information is sufficient for GS. So oftentimes, just because I take you to this much detail in the class, please don't torture yourself. Even if, let's suppose, you are not going into the very depth of it, fair enough. Don't uh, torture yourself that I should know that. No, fair enough. Even if you know that positive IOD is associated with more rain, negative IOD is associated with less rain, your work will be done. So positive IOD basically is associated with more rains. Okay. Rishika, generally, you will observe that in the case of tropical easterly jet stream, that gets into existence after the southern branch has vanished in most of the cases, but it can happen almost simultaneously also, but mostly after the disappearance. Now, when we have the neutral and the negative condition, what is it that we experience? Here you have, by the way, the high pressure, the masculine high. You have the high pressure. It is the high pressure which is driving the winds over to the Indian subcontinent. Right? Because that is moving towards the ITCZ, isn't it? Now here, when you have a neutral or negative IOD, where is the low pressure? Eastern Indian Ocean or Western Indian Ocean? Yes, Sudakshana, that is correct. When you have a negative or a neutral IOD, where is it that you have a low pressure? Very good. Eastern IOD. So here you have Eastern Indian Ocean. Here you have a low pressure. So that becomes a competing low pressure. Competing low pressure. It competes with the ITC set. So here what happens is basically, in this situation, what will happen? The winds which were earlier moving towards India, some of these winds will be attracted and diverted to this low pressure, which means what? Now you will have lesser winds moving over to India. Why? Because much of that wind has actually started moving towards the Eastern Indian Ocean. So, what is the consequence of it? The consequence of it is lesser winds moving over to India. So, that means less than average rainfall. So, competing low pressure in Eastern Indian Ocean, and that means winds get diverted, which means less winds towards India, which means less than average rainfall, or simply less rains, or weak monsoon. That is the condition of a negative IOD. But if you talk about the condition of a positive IOD, what happens in the case of a positive IOD? If I rub this all up, let's suppose there is positive IOD. So what is the condition during a positive IOD? During the condition of a positive IOD, you have warm waters. If I can take you back to the PPT, to the portion here. Uh, so, yes, this is the case of the positive Indian Ocean dipole, isn't it? Observe where you have in the region of the Arabian Sea substantial amount of warm water which is accumulated. So here you have warm water which starts accumulating in this area. This is your low pressure, right? You have the ITCZ, by the way. ITCZ is passing through here, which is the absolute low pressure. ITCZ is reflective of the absolute thermal low pressure. So if I were to ask you, which low pressure is more powerful or more intense? This one at Arabian Sea or this one at ITCZ? Which low pressure will be more powerful? What do you think? Without a doubt, there should not be any doubt. ITCZ will be very, very powerful. ITCZ is the absolute thermal low pressure, the region which gets extraordinarily heated up. That is where the ITCZ eventually comes up and lies there. So the ITCZ is the king of that region in terms of low pressure. But here, when you have a low pressure over Arabian Sea, what it does, it attracts more winds here. More winds are attracted. More winds, they cross over. As they cross over to this area, they will cause some amount of convection, maybe cyclonic rainfall in this area will also be created. But along with that, these winds, now in this area of Arabian Sea, you have a surplus of air and you have a kind of a monster sitting in the northern part of India. That is the ITCZ. ITCZ is the absolute thermal low pressure. So ITCZ is where you have the requirement of the wind. Low pressure means less wind. So here, all these winds will then be thrown and directed towards India. It will cause cyclonic rainfall, sometimes occurrence of cyclones over the Arabian Sea. It can. But then it is a supporting low pressure rather than a competing low pressure. In the case of a positive IOD, it is a supporting low pressure. Supporting low pressure to ITCZ. That means attracts more winds and pushes them to ITCZ. Greater amount of rainfall observed over the Indian subcontinent. Monsoon becomes stronger. Okay, so these are basically the various different factors which influence the southwest monsoon or the advancing monsoon. Now let us understand the mechanism of it, quickly weave a story around it. Let us understand how this entire formation happens. So, okay, yes, Rishika, I forgot that. Actually, good that you basically brought that to the attention. So, and I in fact ask all of you. Rishika had a doubt, but I want all of you to think about it. What is this phenomena in the southern Indian Ocean near Australia? Anjali, which monsoon is stronger? By that, what do you mean? Which monsoon, as in? This is, by the way, a satellite image of the wind pattern. So it is not about Very good, Ravi. Beautiful. It is. Understand, related to the season. At this point of time, which season would be in existence in the southern hemisphere? What kind of climatic conditions would be in existence? Pratik, very, very good. So during winter, what is the probability of what experience will you have? Will there be greater amount of cold conditions? Obviously. So here you will find the presence of anticyclonic conditions, high pressure centers, right? So you will have an anticyclonic condition. Yes, tropical cyclones also develop, temperate cyclones also develop in this area, but this is where you will have the kind of anticyclonic condition. Observe here, this is what you observe. I hope you observe this particular portion. This is where the frontal formation happens eventually. Okay, so you can gain a lot of it if you start looking at the satellite images, but then I understand that you have other compulsions also. Now, after this, we come to, yes, Seema, that is where you have the fronts. That is where in the upper atmosphere you also have the presence of jets in most of the cases. And Tibetan Plateau has low albedo. Yes, that's why it gets heated quickly. Yes, when the snow is melting, that is why. Why we oftenly witness cyclone in Arabian Sea? Because it is getting heated and so on. Chandrajyoti will come to that. What is monsoon trough? So Rohit, basically, when we talk about the summer season, there are distinct low pressure cells other than the ITCZ which are formed over the Indian subcontinent. And these low pressure cells, they basically, so if the ITCZ lies here, you have other low pressure cells which are also formed. These attract the wind. So you have 6 to 7 such low pressure cells which are created in the duration of 5 to 6 months of the monsoon. So those low pressure cells which are created, which create cyclonic rainfall in that region, that is also known as monsoonal trough. So let us talk about the entire mechanism of Indian monsoon. So when we talk about the Indian monsoon, it all begins with the shifting of the ITCZ. The ITCZ lies over the region of India, northern portion of India. Now that ITCZ lying over there means it will attract winds. It will attract winds. And these winds will approach the country from a direction of southwest to northeast. So wind direction is, when we talk about the wind direction, it is basically southwest to northeast. That is why this is also known as southwest monsoon. Okay. Now, then as these winds they come over here, they don't bring rains immediately. As the winds they come over here, they won't immediately bring rains. They will be there because the air is static. Air is not moving at that point of time due to the presence of the southern branch of the jet stream. The moment this southern branch of jet stream disappears, that is when these winds they start suddenly moving. Some amount of rainfall you will receive in the region of Andaman Nicobar, some amount of rainfall you will receive in various areas. But when we say that the onset of monsoon is not said to be that which part of the country receives rainfall first. By that logic, Lakshadweep receives rainfall first of all. Lakshadweep will receive rainfall much before Andaman, much before Kerala. But that is not referred to as the onset. Onset is when you have continuous convective currents which are in existence, continuous wind movement leading to significant cloud formation, bringing about a substantial low pressure, and then a kind of a amount of rainfall received over 5 to 7 day period over Kerala. That is when we declare that the onset of monsoon has happened. It is not about which region receives rainfall first, right? So this is when onset happens, when the southern branch of jet stream. I hope, Musharraf, your question is answered now. of jet stream disappears. Causes sudden increased convective motions, continuous rainfall, rains leading to basically what is also known as burst of monsoon. Okay, that is also what is known as the burst of monsoon. Now, as the monsoon arrival has happened, this is an advancing, this is what is known as the advancing monsoon, where the moist winds will basically spread across the country. And how they bring rainfall? What is the rainfall distribution? So you will have moist winds or moisture bearing winds. They will be hitting the western coastline. This is what is known as the Arabian Sea branch of monsoon. Simultaneously, here you will have the Bay of Bengal branch of monsoon also. Right? Now, here you would observe that the region around Tamil Nadu, Andhra Pradesh, this coastline, this does not receive rainfall during the months of June, July, August, September. Why? Because the winds, by the time they reach here, they don't have moisture, and here the direction of the winds is parallel to the coastline at this point of time. So that is why the Coromandel coast, as it is referred to, is dry. Now the Arabian Sea branch of monsoon gets divided into three parts. That is the distribution. One part of it hits the western coast of the Western Ghats, brings rainfall in the Western Ghats region. It takes almost 10 days for this particular monsoon winds to move from Kerala all the way till Mumbai, Maharashtra coverage. It takes almost 7 to 10 days. Now, one other part of this monsoon moves through the Rift Valley system between the Vindhyas and the Satpura and causes rains in the central portion of India. That is the second part of the monsoon. The second part of the Arabian Sea branch of monsoon. The third part of the Arabian Sea branch of monsoon moves north. Now here, it actually moves parallel to the Aravalli ranges, where in the southern part, due to obstruction, it might cause some amount of rainfall, but the western part of the Aravallis are rendered drier. These will lastly hit the portion of Punjab and Haryana and basically cause orographic rainfall due to the Himalayas in this region by the end June or by the first week of July is when the region of Punjab, Haryana will receive rainfall. In the meanwhile, as soon as this hits the Kerala coastline or as soon as the southern branch of the jet stream disappears, here also there is a rush of wind. That is the Bay of Bengal branch of monsoon. The Bay of Bengal branch of monsoon immediately will hit the Himalayas, cause copious amount of rainfall there. Here it will diverge. One part will go into the northeastern hills, where, as you can see, it will be trapped by the topography. Another part here will get diverted to the west, causing rainfall all along the way. Here, these winds eventually meet with the Arabian Sea branch of monsoon. They cause rainfall in eastern Rajasthan, in the region around Delhi, Haryana, Punjab. So that is where the rainfall by the advancing monsoon is caused in Punjab and Haryana at last. That is the region which receives rainfall last, right? They receive rainfall along with Jammu, Kashmir, etc. So that is where the rainfall reaches in the month of July. It takes almost about a month for the entire coverage of the country by these monsoon winds. In the meanwhile, during the month of end June and July, the Tibetan highlands, they have gotten heated up. They have gotten heated up, so there is a low pressure created on the ground. And I saw few of the confusions out there. Always remember, winds will always blow from a high to a low. And think about it. I don't know why the confusion existed. You said that many of you had written that tropical easterly jet is defying the perspective of wind moving from a high pressure to low pressure. Understand, if you have a low pressure on the ground here you have a low pressure. If you consider the tropopause, the winds are hitting this and then they are diverging. What will be the pressure condition from below as experienced here? Won't this, if this is the tropopause, you have winds which are hitting here, won't this be a region of a comparative high pressure in that case? Right? If you have to think about it like that. But on the ground surface, the winds will always be attracted towards that low pressure, right? As the winds here on the low pressure, they rise up, they will diverge in the upper air. They will diverge in the upper air. They will come to the region of the subtropical high pressure belt, and then you will have the surface winds which get generated, and these surface winds will further strengthen the monsoon. So this is your tropical easterly jet, the upper air circulation of the tropical easterly jet. And then after that, you have the impact of El Nino, La Nina, and also IOD, where El Nino, La Nina, etc., they will weaken or strengthen the mascarene high. So La Nina condition, due to its circulation, it strengthens the mascarene high, makes the mascarene high stronger. Makes the mascarene high stronger. Stronger. Whereas the conditions of El Nino, they make the mascarene high weaker. By the way, if we are comfortable up till this particular point, by the way, you also have what one of you had raised, the concept of monsoonal troughs. What are monsoonal troughs? Monsoonal troughs are basically intense low pressure centers other than the ITCZ, which is formed due to the heating of the land purely. ITCZ follows a kind of a pattern, a long term continuity. But when we talk about monsoon trough, I will just give you a brief idea. I won't go into the detail because it might end up confusing you beyond proportions, and I don't want to risk that. So, this is intense low pressure centers formed on the surface other than ITCZ. It is seasonal, and is formed and is developed during June to September. Just to give you an idea, a brief idea, basically, see, if you don't want to understand, if you don't want to get confused by monsoonal trough, you can ignore it altogether. But just to give you an idea, monsoonal trough is a kind of low pressure cells which get created like this. If you have the ITCZ which passes here, the winds are getting attracted towards the ITCZ. But if these monsoonal troughs won't develop, they won't be able to direct those winds. So these monsoonal troughs, they sometimes shift near the foothills of the Himalayas. They converge with the ITCZ, creating rainfall in the region of the Himalayan mountains, but the rest of the country is drier. These monsoonal troughs, during the month of August, September, they shift southward, causing rainfall in central part of India, flooding across the region of Godavari, etc. But nonetheless, don't get too much bogged down by this. Just understand monsoonal trough is another low pressure developing around due to the heating of the land. That's it. Now, we have seen the impact of El Nino and La Nina. You also have the impact of IOD, where we do know that when you have neutral or negative IOD, you have the wind systems which are attracted here. It is a competing low pressure, means from the masculine high, you have lesser amount of winds which will reach the Indian coastline now. That is why neutral and negative IOD, they lead to lesser rainfall in India. But when we talk about positive IOD, this forms a supporting low pressure to the ITCZ. This will pull more winds from the region of the mascarene high. More winds will be pulled in, and more of those winds will then be pushed towards the ITCZ and the monsoonal troughs. So that is where positive IOD brings high amount of rainfall as compared to neutral and negative IOD, which leads to reduced amount of rainfall in India. Then we come to the phenomena of retreat of monsoon. How many of you till now have reached a stage where you want to simply quit it all and start studying some Times of India or entertainment news? Has that point of saturation been reached? Okay, at least we are honest enough. I'll give credit to that. See, these kind of things you won't find, these kind of situations you won't face in many of the subjects. But for example, if here I were to start talking about what Prime Minister Modi is doing, what is happening between China and India, what is happening between India and Pakistan, I'm sure all the eyes would be opened up. But then, this is a kind, but please understand the concept here is in geography, if you understand one particular base, everything is a follow up to that. Right, there is no kind of a rocket science involved. Everything, it is not like your organic chemistry where you have so many exceptions that you have to write a book for the exceptions. In geography, everything follows logic. At any point of time, anywhere, wherever you face any kind of doubt, just remember one thing. At one point of time, if you had understood that, just apply the principles of temperature, pressure, wind movement. That's it. The entire concept of monsoon can be understood by that. It will happen that 5 days from now, 15 days from now, you might face some doubts here and there. Don't get perturbed by it. That what has happened, why I have not understood. No, it will be understood. It will be solved. Approach it from the very basic. Is there heating? Will there be a low pressure or not? If yes, still if it is not happening, is there any other factor involved? What is that other factor? Is there some influence in the Indian Ocean? So if you approach it like that, if you attack it on the base, it can be solved. So it is very much like science or mathematics. If you follow the process, you will reach the result in it. But nonetheless, when we talk about, yes, tropical easterly jet is temporary. Yes, Payal, that is correct. So when we talk about masala is what we are habitual to. That is true. I know that. I know that. I know the interest that is peaked as soon as somebody talks about India, Pakistan, what Modi ji is doing, what the opposition party is doing, which party has got majority in the parliament, what is the perspective of the 2024 election, where a disaster has occurred, what is happening with India, Canada. Immediately interest will be piqued. What actually were the Mughals good or bad? Were the revolutionaries good or bad? This will pique interest. But the sad part is UPSC doesn't ask these questions. Otherwise, we could have spent the entire thing on these discussions only. But UPSC asks some very different questions. Now, here, when we talk about the retreat of the monsoon, what is the retreat of the monsoon? When we say the retreat of the monsoon, it is basically the withdrawal of the ITCZ, the withdrawal of the entire monsoon phenomena. So, this withdrawal of the ITCZ starts happening when you have the southward movement of the sun. So this retreat of the monsoon is generally initiated after 17th of September, right? So this is generally initiated after 17th of September. It is not that 17th of September there will be Vishwakarma Puja, only then the ITCZ will start withdrawing. It is not like that. Around 15, 16, 17, 20th, that is the period when the ITCZ starts withdrawing. So the ITCZ starts this year in November. Who told you? Where do you get these all kind of informations? Starts moving. This year the retreat was completed by 14th of October. Starts moving south. Continues for a month or two. Chetri, remind me about that question at the end of the class. We are trying to lower the level of confusion. If I address your question, it will always increase that amount of confusion. I'll answer your question at the end. So continues for a month or two. So from September onwards, it is initiated, and basically it carries on all the way up till the month of around sometimes late October, sometimes even up till November. So what is the process? The process is that if you consider this the ITCZ, now after few days, this ITCZ starts moving like this. This ITCZ in the month of October will be here, right? So if it is there in the month of October, means what? What about the wind direction? The wind movement now will be, the winds are actually going towards the ITCZ, but now you will have the northern trade winds also setting in. Again, observe the pre-existing low pressure system is lying over the region of Arabian Sea and Bay of Bengal. And whenever you have a pre-existing low pressure, already existent low pressure, always there can be a generation of a tropical cyclone. That is why from October, again, as this ITCZ lies over the region of Bay of Bengal and Arabian Sea, that triggers another season of cyclones. That is why after 4 to 5 months of silence, Bay of Bengal as well as the Arabian Sea start experiencing cyclones. Now here, furthermore, it shifts further south. Let's suppose it shifts slightly further south. Let's suppose it reaches here. By the month of November, December, it reaches here. Now observe the wind movement. This wind is moving over the dry areas, over the land areas. So they won't bring any rainfall anywhere. But you have one component of the wind which after crossing Bay of Bengal will hit the Tamil Nadu and the Kerala coast, Tamil Nadu and the Andhra coast and the Coromandel coast. So that is why during these months or during the retreat or the withdrawal of the monsoon, Coromandel coast receives rainfall. Yes, these are trade winds. So here, wind direction is, what is the direction of wind over India? Wind direction here is northeast to southwest. That is the wind direction. Observe, it has reversed as compared to the advancing over the Indian mainland. Now it has reversed. Coromandel coastline coast receives rain. Right? Coromandel coast, which was dry during the advancing monsoon, Coromandel coast receives rainfall up till the month of, during the month of October, November. Right? So this is the case of withdrawal of the monsoon, where the entire system is withdrawing from India. That is the retreat of the monsoon. Direction of wind pattern is northeast to southwest. So observe that retreat from around 1st September, 15th September onwards. Observe it has started retreating. 1st October, this is where the low pressure system was. Observe by the month of December, eventually it withdraws. But that again means that during the month of October, November, December, some or the other portion of the ITCZ, early part of December, some or the other portion of ITCZ will either lie over Bay of Bengal or Arabian Sea, which can trigger a massive cyclone also. Okay? Now, another factor, and that is the northeast monsoon. The sad part is that many of the study materials, many of the books, and also many of the tutors available online and everywhere, they tell you that northeast monsoon and retreating monsoon is the same. That is the sad reality of it, but it is not same. Northeast monsoon is different from retreating monsoon. Keep that in your mind. Northeast monsoon is a different phenomena which gets into place after the withdrawal of monsoon has happened. This gets into existence after the withdrawal of monsoon has happened. So, why is it that people confuse it with the retreating monsoon? Just because the direction of the wind is the same. That is why. That is the only reason. This sets in after the withdrawal of monsoon has been completed. Now, what is this northeast monsoon? Northeast monsoon is also a kind of a very similar concept where the winds will get attracted towards the ITCZ. But this time, we are talking about the month of mid-November, December, and January. During these months, from December, January, mostly December and January is when it is experienced. During these months, where is it that the ITCZ will be? ITCZ would have started returning to its original position. The ITCZ would come here, let's suppose in late December, mid December, or January. That is the ultimate destination of ITCZ. Now, what that means is basically you have the trade winds which will get attracted here. The trade winds, the southern trade winds will get attracted here. What about the northern trade winds? Northern trade winds, they start moving towards the ITCZ. Now, over the land areas, they won't cause any kind of rainfall. No rainfall over the land areas. But as they will cross the Bay of Bengal, they will hit the Coromandel coastline and they will bring rains in Coromandel coastline. You have the regular pattern of winds which are generated here. Sri Lanka also receives rain during this. So this is basically where the wind direction is same. That is northeast to southwest. That is the same wind direction. But then here, which receives rainfall? Again, the same area. Coromandel coastline gets rainfall. You know, it is during this time, those of you from Tamil Nadu, those of you from the region around Chennai and in the coastline, it is during these months when, again, around 15th of December onwards, where you have another batch of paddy which is sown. Right here, you have three different varieties of paddy, three different batches of paddy which are grown in the coastal Tamil Nadu. And because of the sufficiency of moisture, they are able to do so. Andhra, at the coastal Andhra, they are also able to do that. So that is basically the northeast monsoon setup. So what do you observe? If you observe the movement of winds during the month of June, July, what was it? Southwest to northeast. Now, what is the movement of the wind? Northeast to southwest. So, you have achieved a complete reversal of wind movement. And that, my dear friends, is monsoon climate. And that is a true monsoon. However, when we talk about the monsoon, you have a phenomena which is referred to as a break in monsoon. What is that? So, all of you would have experienced basically that after, let's suppose, the rainfall has, or the monsoon, everybody has announced that the monsoon has arrived, the monsoon has come. After that, you would have come across a phenomena where suddenly, for 5 to 7 days, there is no rainfall. And all of you wonder that did monsoon indeed come? But we are not receiving rainfall anymore. So, what is that? So, when you have that gap of 5 to 7 days or 10 days after the onset of rain monsoon where you don't receive any rainfall, these are known as breaks in monsoon. So, what are these breaks in monsoon? When we say break in monsoon, basically, why does that happen? So, let's suppose we are talking about two places. I'll take the examples, let's suppose Indore, Bhopal. Now, Indore, let's suppose, has got that low pressure, the monsoonal trough receives very heavy amount of rainfall. Bhopal is dry. Now, over a period of 4 to 5 days, what will be the temperature in Bhopal over the period of next 5 to 7 days? Temperature would increase, isn't it? This will get hotter and hotter. But what about Indore? Indore is receiving rains continuously. 5 to 7 days, Indore will be much cooler, isn't it? Indore will be significantly colder, right? So, comparatively, Indore in those 5 to 7 days will develop a comparative high pressure. And there, this will develop a low pressure. So, that would mean what? That this cloud system would travel here. It would bring rains here. Whereas the region of Indore, in that case, would be left high and dry. So now, unless and until Indore develops that low pressure, Indore won't receive that rainfall. So for Indore, it is a break in monsoon. Similarly, when we talk about the region of the Western Ghats, the western part of the Western Ghats, so here, let's suppose these are your Western Ghats. Now, it might happen that you have normally the winds which are coming here, but suddenly there is an acute or intense low pressure which develops here. So, what will happen? All these winds will be diverted towards that low pressure. Winds don't know what is Kerala, what is Karnataka, what is Maharashtra. Winds only know low pressure. So, in this manner, the winds suddenly are blowing across the western coast, but they are moving parallel to the Western Ghats. What does that mean? No rainfall. So, again, a break in monsoon. So, when you have these low pressure systems which start developing in different parts, that changes the wind pattern in many of the areas, and that brings about break in monsoon. So, after rainy periods, if rain fails to occur for 1 or more weeks, it is known as a break in monsoon. Dry spells are quite common during the rainy season. Breaks in different regions are due to different reasons. In northern India, rains are likely to fail if the rain bearing storms, the low pressure centers, are not very frequent over the ITCZ. And over the west coast, the dry spells are associated with the days when the winds blow parallel to the coast because you have a low pressure developed somewhere. But then, this is the case when the monsoon has arrived. Prior to the arrival of monsoon, before the onset of monsoon, also some regions they receive rainfall. Not very heavy amount of rainfall, but they receive some amount of rainfall. That rainfall is what is known as the pre-monsoon shower. These are small isolated convective rainfall. In small areas, due to the process of convection, they receive rainfall. If moisture is available in the surrounding areas, more evaporation will happen, more cloud formation, and more rains. So that is what is pre-monsoon shower. It is known by different names in different areas. For example, in the region of Karnataka, this rainfall happens prior to the occurrence of the monsoon in Kerala and coastal Karnataka, and they help in the ripening of the mango fruits. That is why they are also known as mango shower in that particular area. For example, when we talk about the region of West Bengal, Assam, there in the last weeks of April and during mid May, also end May, that is when, mostly mid to end May, what you observe is that you have significant amount of convection evaporation forming very dense cumulonimbus clouds by the evening, causing thunder, lightning, and heaviest amount of rain. Now that is why it is known as Kal Baisakhi, right? It is Kal Baisakhi or the Nor'westers. These are Kal Baisakhi. That is a calamity in the month of Baisakh in Bengal and Assam. In Assam, in fact, it is also known as Bardolisira, but then in the region of West Bengal, it is Kal Baisakhi. Now, this brings substantial amount of or some amount of rain prior to the monsoon months, right? And this is helpful, significantly helpful, even when we talk about the cropping of or the planting of crops such as jute. Jute requires some amount of rainfall even prior to the monsoon. So it is helpful in the planting of jute also. Okay, so that is where it is beneficial. That is the case of the monsoon. So basically, what do you observe in the case of the wind pattern or the monsoons? We have in the monsoons the arrival of monsoons, and then you will observe that the wind pattern in general, the Arabian Sea branch of monsoon here is like this, isn't it? Like this. And here the Bay of Bengal branch of monsoon is like this. So if I ask you a question, in the region of Bihar here, what is the direction of the Bay of Bengal branch of monsoon, or the monsoon winds are coming from which direction in the region of Bihar? It is coming from east to west, isn't it? It is coming from east going to west, isn't it? Right? So that is why, as the winds are coming from east, means in Hindi, in the colloquial Hindi language, it is also what is referred to as the eastward winds or the Purvaya. It is this question which was asked in this year's Spain's examination. That what is that Purvaya? Many of the candidates, they simply flipped out of their head that I have not studied that Purvaya, where this Purvaya has been asked from. But if you read the English portion of it, it is the eastward wind. So in the region of Bihar, if you experience an eastward wind, where is it coming from? It is coming from the region of Bay of Bengal. Okay, so that is basically the aspect and the concept of monsoon. You missed northeastern monsoon? Nirbhay, are you sure I missed North Indian monsoon, or is it you who missed the North Indian monsoon? Observe North Indian monsoon, my dear friend. Observe the text written. Is it the case that we have missed the northeastern monsoon? No, my dear friend. Kindly be refreshed. Now, during the winter season, the ITCZ has now shifted to the south. As the ITCZ has shifted to the south, along with it, all the pressure belts have also shifted to the south. Now, the pressure belts have shifted to the south, and we are talking about the winter months. So, generally, at this point of time over Indian subcontinent, in the northern part, you have the prevalence of which winds? Westerlies, because the subtropical high pressure belt would also have shifted to the south. So you have the prevalence of westerlies. Meanwhile, something interesting happens in the region of Mediterranean Sea. In the region of Mediterranean Sea, observe here, we are talking about winter months. That is in the month of November, December. It was asked in the mains exam, my dear friend. Jan, Feb, in these months. So in these months, temperature of the land mass will be very, very cold, isn't it? Comparatively, Mediterranean will be warmer. I hope we are comfortable with this. Are we comfortable? Right? So temperature of land will be very cold. This will be very cold. This will be comparatively warmer. Can we expect a frontal formation here? Because you will have warm air above Mediterranean, cold air above the European landmass. So there will be a frontal formation. That frontal formation means there will be rising air. Wind will rise up from here. It can create a disturbance, and it creates a temperate cyclonic disturbance. Now, this temperate cyclonic disturbance, along with the cloud cover, etc., everything, basically, it moves, carried by the westerlies. This moves from a direction of west to east. It crosses the portion of West Asia. It crosses Iran, crosses Afghanistan, crosses Pakistan, and then encounters the mighty mountains that are Himalayas. It hits the Himalayan foothills. And in the region of Himalayan foothills, it will cause snowfall. This is the time when Jammu Kashmir, Ladakh, in some portions, Himachal Pradesh, Uttarakhand, they will receive heavy snowfall. So, Himalayan foothills receive heavy snowfall. But then the other areas such as Punjab, Haryana, Delhi, UP, sometimes all the way till the region of Bihar, right? You have these westward movement of winds. Bihar, Bengal, sometimes in rare cases all the way till Assam plains. These areas, they receive rains. Now, these rains are brought by the atmospheric disturbances which are coming from west to east. And that is why these are also what are known as western disturbances. Again, let's suppose this travels here. Let's suppose this travels here, this reaches here. And again, after a few days, there will be another of this disturbance which will be created. Another of that disturbance will travel. Right? So that is why in the month of November, generally you have 2 to 4 of such disturbances which travel. That is the reason why Delhi would receive rainfall and northern part of India would receive rainfall twice or thrice during the month of November. In the month of December, this increases to 6 to 7. Okay. And yes, that happens all the way in the region of even northern Rajasthan, northern Madhya Pradesh also. Again, here in January also it will happen 6 to 7 times. In the month of February, it starts decreasing 4 to 5 times. In the month of March, maybe once or twice. So this is your western disturbances. So western disturbances is basically the low pressure systems which originate over the Mediterranean Sea and Western Asia and move into India along with the westerly flow, the movement of the westerlies. They cause the much needed winter rains over the plains and snowfall in the mountains. And locally, they are known as Mahavat, is important for the cultivation of rabi crops such as wheat and mustard. Right? There, it is beneficial. So, why does it cross Iran, Afghanistan, Pakistan, not causing rainfall there? Because you don't have that high of a mountain system which can provide an obstruction. So that is why you can see that these western disturbances, how they travel and reach India. Okay. Now, that is the case of the entire climate of India. That is why you observe that the amount of rainfall in India tends to reduce as you move from south to north, tends to decrease as you move from east to west. Why? Because you are moving away from the source of moisture. That is why. That is why the amount of rainfall tends to reduce from south to north and from east to west. Now, here you observe that the western part of the Western Ghats, very high amount of rainfall. Northeastern region, very heavy amount of rainfall. Andaman Nicobar, very heavy amount of rainfall. Vidarbha region, Maharashtra. Uttar Kannada, Northern Karnataka, Telangana, dry. Why? Leeward side of the mountains. Here, Western Rajasthan, dry. Why? Winds are parallel to the Aravalis. Okay, Ladakh, dry. Why? On the leeward side of the mount of the Himalayas. So this is about the distribution of rainfall. When these western disturbances occur, by the way, the western disturbances, they intensify the winter. That is when you would hear the cold waves, they come in. The winter gets much more stronger and intolerable sometimes. That is because when the Himalayan foothills, they are receiving very heavy amount of snowfall, very excessively heavy amount of snowfall. All that snow basically generates these cold winds. And also the rains in Punjab, Haryana, Delhi, Western UP, sometimes even Eastern UP, Bihar, Bengal, it worsens the winter condition, makes it much more colder. Let's take up a few questions before we end the session. So, which of the following correctly describes the phenomena of Western disturbances? These are aggravated monsoon winds blowing from west to east. They originate over the region of Mediterranean. I'll give you 15 seconds for this. They originate over the Mediterranean Sea and are carried to India by winds. They can be felt mostly during the months of July to September. They can bring rains over the hilly tracts of Himachal Pradesh. Musharraf, western disturbances, when they occur in the month of November, December, they are helpful for the planting of the crop. But if this brings about thunderous rainfall in the month of March and April, when the crops need to be harvested, that is when it can be destructive for the crops also. Sheikh Baisakh is basically a month. In the Hindi calendar, you will observe that Baisakh is a month, and you have the festival of Baisakhi also. So that is when, if you have the thunderous showers in the region of Bengal, it is known as Kal Baisakhi. In the region of Assam, it is referred to as Bardolisira. Consider the following about the statements about the phenomena of El Nino and its effects on Indian monsoon. It occurs in the region of South Pacific and hence has no impact on Indian monsoon. It leads to increased rainfall over Indian subcontinent during the monsoon season. Its impact can virtually be neutralized by Indian Ocean dipole and Madden-Julian oscillation. Why no rainfall in Pakistan due to western disturbances? That is what I told you, Nirbhay, that in the region of Pakistan, you don't have that mountainous obstruction. However, in the Punjab province of Pakistan, you will receive some amount of rainfall. In the western frontier provinces, also you'll receive some amount of precipitation, but there is no Himalayas. That is why closer to the Himalayas, you will experience rainfall. Punjab, Haryana, UP, Bihar, these are very close to the foothills of Himalayas. That is why they receive rainfall. Okay. So here, good majority of you are correct. It occurs in the region of South Pacific and has no impact. Incorrect. It has an impact on Indian monsoon. It leads to increased rainfall over Indian subcontinent during the monsoon season. No, it leads to reduced rainfall. Its impact can be neutralized by Indian Ocean dipole and MJO. That is correct. With reference to retreating monsoon, consider the following statements. The Coromandel coast receives heavy rainfall as a result of this. It generally spans over a long duration from September to November. I'll give you 30 seconds. The movement of winds is from southeast to northwest. Which of them are correct? Atharv, why the cyclones after landing they cause so much destruction? They cause destruction in the coastal areas itself because they bring with them very heavy movement of wind, very strong movement of wind. It is not as if immediately they touch the land and they will disappear, right? They slowly start weakening and they will dissipate after a particular depth in the land, maybe 100 kilometers, 50 kilometers. But in that duration, they will carry the strong winds and heavy amount of rainfall. That is why they will bring destruction. It is a kind of a logical thing, but nonetheless. So here you have the Coromandel coast receives heavy rainfall as a result of retreating monsoon. It generally spans over a long duration from September to November. The movement of wind is from southeast to northwest. No, movement is northeast to southwest. So the correct answer is A, 1 and 2. Okay, so that is where we'll restrict ourselves. Leaderboard, I'll show the leaderboard. So this is your leaderboard. Swaroop, Pratyesha, Aniket, Akhilesh, all of you. Good, very good. Okay. Chetri, yes. Yeah, this is your question. Um, Ritika, your question was that we experience which type of lapse rate in mesosphere? You experience a positive lapse rate because you move up from the region of the heat source, that is stratosphere. Chetri, your question is that if El Nino occurs in the month of December, January, how will it have an impact next year? Listen to this carefully. When we talk about rainfall, the condition of El Nino, you have warm waters here in the month of December, January. With the help of the various different ocean currents, it slowly and steadily moves. You have a weak ocean current that is known as the Lewin current. So in the it takes it almost around 5 to 6 months to reach here. So by the time that the monsoon arrives, the warmer waters would have reached the eastern Indian Ocean. That becomes a distraction for the masquerade high. It becomes a competing low pressure. That is why, if let's suppose El Nino has happened now, next year's monsoon will have lesser rainfall. Conversely, if let's suppose you have La Nina condition, warmer waters are here. So in those 6 months duration, the warmer waters by the oceanic circulation will be able to reach here. Now this will support a kind of the ITCZ or be a supportive low pressure. That is why it creates more rainfall in India, just like a positive IOD. I hope that is understood. And in troposphere, we experience the same. Yes, in troposphere also you experience a positive lapse rate. Okay. And Vishwas, why nowadays in Maharashtra rainfall is happening? What are the reasons? So you have the oncoming of the westerly winds, which are becoming prominent as of now, and that is basically the reason for it. That means western disturbances are basically temperate cyclones or temperate disturbances reaching India. Yes. Okay. Nearby northeastern monsoon. Understand, I don't know where your connection went, why you think that northeast monsoon was not discussed. Look at the recordings, my dear friend. That is all that I can suggest to you. Northeast monsoon sets in after the withdrawal of the monsoon has been completed, where the ITCZ shifts to the south of equator. You have the northern trade winds which get established. These northern trade winds, because they are moving over the land mass, they are dry, they don't bring rainfall. But some of these trade winds, they cross over from the region of Bay of Bengal. Then they carry moisture, they hit the Coromandel coastline. That is when they will be able to bring rainfall in the Tamil Nadu coastline and Andhra coastline. The direction of movement is northeast to southwest. It carries on for the months when the ITCZ is fixated here. That is for the months from mid-November, December, January, sometimes till February, brings rainfall only in the region of Coromandel coastline. That is what is northeast monsoon. Is that understood now? Yes, Vishwa, some amount of these jet streams they do bring. What determines the withdrawal time of monsoon? It is the heating of the land, the cooling, heating and the cooling of the land. Okay. Rest of the questions we'll take up tomorrow, my dear friends. We'll end the session here today. We meet again tomorrow where we study about the world climate and we move ahead. Okay? So that will be all from my side. See you tomorrow. Thank you.